Good morning. I'm in the. Good morning. I think we should start the sessions. We are already late by 45 minutes, and we gave this time to see that if some good volunteers or students come in and listen to the speakers. They are all from respected speakers from the industry, and we should encourage them and learn whatever they speak. Today's first speaker will be Mr. Rajan Sinarkar, Director Sales of Emerson Process Solutions. He will be delivering CSIR ICT Avans Padma Shri Dr. G.S. Sidhu Chemcon Distinguished Speaker Award. Mr. Rajan Sinarkar is the director of the flow products of Emerson Automation Solutions. He is leading Green Hydrogen Initiative for India. He has over 29 years of experience in the field of industrial automation. He is subject matter expert of flow technologies and analytical instrumentation field. He is a well-known speaker and has presented at many forums. Mr. Rajan, your floor, please.
Thank you and good morning to everybody.
You have to switch on the bass.
Hello. Hello. Yeah. Right to aa gaya. Hello. Very good morning to everyone. So our today's topic is hydrogen, the fuel of the future. So this is the agenda which I have thought for today. Of course, quick overview on the Emerson, what we do, and then why green hydrogen. That is the fundamental thing, why everybody is talking about the green hydrogen. Then challenges and the government's role or the initiative what our government is taking for developing India on hydrogen economy, because that is very vital going forward. Then the challenges, the hydrogen production routes, different production routes, then value chain for the hydrogen, then India Green Hydrogen Roadmap, what our country has decided, then hydrogen demand outlook, and outlook on the green hydrogen price, how it will be, because that is finally going to matter when it comes to the, any adoption has to happen in the field, it has to be competitive. And then automation solutions across the hydrogen value chain, what we offer from Emerson. So just a quick overview. Emerson founded in 1890, so it is about more than 130-year-old company. It is about $18 billion company today, and we are having more than 20,000 patents, active patents, because Emerson believes in investing a lot when it comes to basic research and development and product development activities. We have about 87,000 employees all over the world. We have more than 170 manufacturing locations across the globe, and we have very strong presence when it comes to India. We have a lot of factories in India, we have a lot of engineering centers, we have a lot of innovation centers, where a lot of product development activities also happens in India for all the global products what Emerson sells. So today, when we talk about the automation solution, Emerson Automation Solutions, we have different business units. First is the measurement instrumentation. We call it as a MSOL, that is measurement solutions, which is basically pressure, temperature transmitters, level transmitters, flow transmitters, different type of analytical instruments and analytical systems, tank gauging systems. Then we have, and the brands which you must have heard, the Micromotion and the Rosemount, these are the two brands belongs to the MSOL in this particular business unit. Then we have valves and regulators, basically Betis, Fisher control valves, different type of control valves. Then control systems, the distributed control systems, even the PLCs. So on the DCS, the one of the strongest brand we have today, which is widely used in different chemical industries, is Delta V, and Ovation when it comes to the power application specifically. Very, very strong brands we have in the control systems. Then we have ASCO, then Appleton and Branson. So this is about the overall automation solutions. So today, before we talk or start discussing about the topic, that is green hydrogen, just look at the statement which Jules have made 100 years back or more than 100 years back. So he clearly says that I believe that the water will be one day employed as a fuel, and that hydrogen and oxygen which constitutes it, used singly or together, will furnish as an inexhaustible source of heat and light of an intensity of which coal is not capable today. So water will be coal for the future. So we are very close to that. Now we are talking about hydrogen, which is part of the water. So just imagine the kind of what future he can see. He could see so many years back, and we are now today coming very close to that. So let's understand why green hydrogen. So why everybody suddenly starts talking about the green hydrogen? So many days we have been talking about the energy efficiency, and now since last 2-3 years we have been everybody is talking about the green hydrogen. So most important is that the energy demand is going up, and it is going up, exponentially every year. At the same time, the requirement is that the carbon footprint has to go down because of the climate change and all those challenges and pollution challenges. It is critically important that you reduce the carbon footprint. So how these two things can go simultaneously? If the energy demand is going up, you are using the fossil fuel, you are bound to pollute, you are bound to, exhaust more CO2 in the atmosphere, whereas that is not allowed. So the only solution, sustainable solution for that is green hydrogen. Because when you use hydrogen as a fuel, you don't exhibit or you don't exhaust any CO2 in the atmosphere. So this is completely clean fuel, you can say. And that is the reason everybody have started talking about the green hydrogen. Few other points like UNFCCC, the Conference of Parties in 26, our PM promised that India will be net zero by 2070. So India being developing countries, we have been allowed for 2070, but most of the developed countries, they are targeting it as a 2050 as a net zero target. Now we are talking about 2070, but yes, our programs are actually aligned so that we can achieve most of the things by 2050 itself. And a lot of such initiatives and actions are there. Today, if we talk about specifically about the India, it is not only the pollution, but the other governing factor, which is today we are spending about $160 billion today just on the energy import. It's a huge amount of money, huge amount of foreign exchange we are spending every year just for importing the energies. Just imagine if we can avoid that, what will happen to the India? The progress what we can get in India is enormous. And if there is no corrective actions taken, this will double in next 15 years. So it is like critically important for a country like India that we adopt and progress very quickly on hydrogen economy. India needs to be energy self-reliant. Today, whatever is our energy consumption today in India, 80% of it we have to import. Whatever ONGC, Kane and Oil India, they produce the crude, it is just sufficing to 20% of our consumption what we have in India. So it is important that we have to become energy self-reliant, and when it is hydrogen, we really don't depend, we don't have to import anything. Second is that, of course, India should aim for, as our Prime Minister also mentioned during August 2021 speech, that India should aim as a global hub for green hydrogen. So we should not only produce hydrogen to suffice our energy demand, but we should actually aim to export the hydrogen. And of course, it is our moral responsibility to hand over the safer and greener earth to the next generation. So looking at all those things, I think it is inevitable that we have to go to the hydrogen path as quickly as possible. So before going to that, let's quickly, everybody is here, this is a chemical event, you guys are expert on chemical, but just to recapture before starting the next sessions, let's understand what is the basics of hydrogen, the fast facts of the hydrogen. Hydrogen is not a new, molecule, it is known since so many years. And it is abundantly available in the nature, but unfortunately it is not available as in the pure form. So you need to extract hydrogen from either fossil fuel or biomass or water. So when we talk about the green hydrogen, it is basically splitting the water and getting the hydrogen from the electrolyzers, and of course use the electricity from the solar or wind energy, so that you don't generate any CO2 again for generating the hydrogen. So the another important thing is it is colorless, it is odorless, it is non-toxic, which is good, but it is highly combustible. So spectrally it is the symmetrical diatomic atom, so it is spectrally blind, IR, infrared absorption, it doesn't absorb any infrared radiations. Low energy density. When we talk about on the mass basis, if you look at on the mass basis, it is the density is very, very high. But the problem is that on the volumetric basis, the density is very low, because hydrogen being the lightest component, on the volume basis it is low, and that pose some challenge when using hydrogen or transporting specifically and storing the hydrogen. You have a challenge. The flame is invisible. In the picture you can see that you can see the flame for propane or any fossil fuel flame, but when it is hydrogen flame, it is invisible. So these are some of the things which we need to take into account when we design or try to do anything in the hydrogen value chain. So the challenges is today, whatever hydrogen demand we have today in the industry, most of the hydrogen is being produced from the fossil fuel. And the cost of producing hydrogen from the fossil fuel is lowest today. If you have to produce the hydrogen, green hydrogen, using the renewable energy and water, the cost is almost 3 times to 4 times higher. So that is one of the challenge, and that is the reason it is like chicken and egg story. That is the reason the adoption rate for the hydrogen is also low. Second is infrastructure has to be developed quickly in India for production, right from production to transportation to storage and mobility. So you need to develop the huge infrastructure today. So that is the another thing which we need to handle when we have to really develop India as a hydrogen economy. And second is, of course, developing some basic research and development on manufacturing capabilities locally. That is important, specifically when it comes to electrolyzer technology, how efficient we can produce the hydrogen using the electrolyzer and fuel cells. Now let's look at the hydrogen initiatives what government has taken for developing India as a hydrogen economy. First is our PM launched the National Hydrogen Mission in 2021, and this year they have already unveiled the Ministry of Petroleum has unveiled the hydrogen policy in February 2022, the government has given some time-bound mandates to a lot of public sector units that to increase the green hydrogen share in the overall energy mix. PSUs, a lot of PSUs have launched the pilot projects for hydrogen, whether it is production or even mobility or dispensing unit. A lot of you must have seen some tenders came out from NTPC for hydrogen dispensers in Leh and Ladakh. So a lot of such activities are going on, and I think we are on the right path. And with supportive government policies, a lot of business houses have announced big mega hydrogen projects. So the production routes, when we talk about the production routes, first one which you see on the left side is green hydrogen. That is the splitting the water using electrolyzer, and you feed the electrolyzer electricity from the renewable energy like solar and wind. So that is green. If you use the normal steam methane reformer for and natural gas, then it is called as a grey hydrogen. And instead of emitting the CO2 in the atmosphere, if you capture that CO2 and don't allow it to be emitted in the atmosphere and use it or store it, then it becomes a blue hydrogen. Same way, brown hydrogen, if you use coal gasification, that process, then it's a brown. If you use direct grid electricity, then it's a white hydrogen. Now, on the pie chart, you can see these are the end uses or for the hydrogen. So biggest today is still the hydrogen which is being used in the refining process, is refining which is the largest end use when we talk about the hydrogen. Then you have of course ammonia, heating applications, methanol and various chemical processes where you use hydrogen as a feedstock. On the top charts, the horizontal chart which you see, which shows you that if you try to produce the hydrogen using the coal-fired things, then for every production, every kg of hydrogen production, you are actually emitting 35 kgs of CO2. So it's very clearly no point in producing hydrogen using the fossil fuels. And the bar chart, what you see here in 2020, like 70 MTPA, in next 10 years, it is going to go from 70 to 100. Today, as of today, the overall hydrogen production, you see that there is absolutely no green hydrogen. In 2030, you will see that there will be a good amount of hydrogen share, green hydrogen share, which will come in. And by 2050, most of the hydrogen produced will be green hydrogen and some percentage will be blue hydrogen. So these are just three buses, we call it. One is electricity, second is hydrogen, and third is natural gas, and how they are interlinked. If you use these, for example, renewable source and electrolyzer, then it produces hydrogen. How this hydrogen can be used back to generate the electricity using the fuel cell, which is exactly opposite as that of the electrolyzer. Same way from natural gas, how you can produce the hydrogen. From hydrogen, again, you can produce the natural gas, which is called as the synthesis gas. And then what are the end uses for the hydrogen? So today, if we have to go to the hydrogen economy, I think it is, you cannot start immediately thinking that hydrogen will be used in the mobility and for various energy applications. It is important that what is the low-hanging fruit today, that from where we can start the adoption of green hydrogen, is the feedstock which is used in the industry for hydrogen. And of course, the biggest feedstock comes in the applications like refining. If you, as we have seen in the earlier chart, that government has given the mandate that it should be green hydrogen. So that is the low-hanging fruit. We can very quickly start adopting or using the green hydrogen in the refining process first. And the ammonia, of course. Ammonia is also important because for transportation, as we have seen that there are some challenges because of the basic properties of hydrogen. For transportation, rather than transporting hydrogen, you can transport green ammonia very comfortably. And green ammonia, you have today marine route which is available today from through which you transport the green ammonia. And then the city gas distribution in the CGD pipeline, natural gas pipeline, which is, we have already huge infrastructure developed by GAIL, where natural gas pipelines, you just inject about some few percentage of hydrogen, even that will, help to reduce the carbon footprint. So these are some of the low hanging fruit. So this will be a path, and then subsequently as we go forward, then for the steel manufacturing, you can use hydrogen for direct reduction, and you can really use it as a green steel, which will have demand globally. And then domestic steel production, heavy duty trucking. So when we talk about the really mobility sector, the light vehicles will not be really low hanging fruit, but when it comes to heavy duty trucking, specific areas like Mumbai Delhi corridor, so there you can target the hydrogen to be used as a green hydrogen for fuel. Today, if we look at again, these are the bar charts which are showing the hydrogen consumption, what is there today. And the yellow dots which you see is the green hydrogen share. Again, it is almost like zero. In 2030, almost 50% of the hydrogen has to come from green hydrogen sources. And 2040, if you see, the dot is above the consumption. So that means that is the time from 35 to 40, we are planning that we should be able to fulfill our complete energy demand or hydrogen demand from a green hydrogen, and not only just suffice, but you will start exporting hydrogen by 2040. And of course 2050 we will suffice completely. These are some of the mandates. If you see on the bottom table, that is refining, 50% of the hydrogen has to be from the green hydrogen source, and almost 100% from green ammonia. Why we are start giving more aggressive target to ammonia? Because so that you can start exporting. If you are geared up for manufacturing green ammonia, you can gear up for even export green ammonia. So these are the cost structure when we talk about the hydrogen. Today when we manufacture the hydrogen using the fossil fuel cost is one of the important cost factor for deriving the overall hydrogen cost. And then of course you have foreign exchange, because you are spending almost like 80% you import. So for spending of foreign exchange is also important cost factor. And then of course transportation and storage. When we talk about the green hydrogen, the electricity cost is the most important thing, and that has to be from the renewable energy. One good thing is that India has geared up a lot when it comes to the solar energy. We have a lot of capability developed already, and we are manufacturing electricity competitively today. And so that is not really an area which is concerning us. In fact, that is the strength, I would say, for India. But the electrolyzer cost can be a concern, because today the technology is not developed in India. We have to import electrolyzers, and that will be a major capital cost where you need to focus on. So this is about the cost structure when we talk about, and where we really need to focus. When we talk about the immersion, so we are taking the hydrogen, or overall sustainability program is driven by Mike Train, who is like number 2 in the our board, and he himself is our chief sustainability officer. And there are 3 pillars which we look at when we talk about the sustainability. Is greening of immersion. That means whatever we do in our factories and manufacturing and operations, how we can produce everything completely green. So that is the area where we focus. And then of course greening by immersion. That means how do we partner with our customers in their greening journey with our intelligent products, whatever we have, like field instrumentation and automation solutions, and greening with like the forums like this, where we participate actively with the government. Also we are participating actively. We are part of the India-US Hydrogen Task Force. So on the bottom you see the overall hydrogen value chain, right from renewable energy, that is solar or wind, then hydrogen production using the electrolyzer, then the gas blending, where you blend hydrogen in the natural gas pipeline, for example, storage, distribution, hydrogen dispensing and mobility, and of course the consumers finally. On the above that, what you see is the number of products, specifically the field instruments, what goes in the overall value chain, right from control valves to pressure transmitters to flow meters and various other field instruments, even analytical instruments like gas chromatographs, process gas chromatographs, gas analyzers, which goes in the value chain. And then above that, of course, which comes is the control part. So the DCS or the PLCs or individual controllers, we have complete solutions, and most of these solutions are actually tailored for the hydrogen applications. And of course, above that is the software part, whatever you need for energy management system, generation management system, and different gamuts of softwares what we have today. Just to give you a brief overview on the field instrument which goes really, or even the DCS which goes in the production area, in the green hydrogen production, that electrolyzer, what are the instruments which goes, then storage and transportation, what goes in the storage and transportation, what goes in the utilization. So again, when we talk about the green hydrogen value chain, so it starts from production to the electricity and production, and then the transportation, the pipeline, and then the mobility, which is end use. So we will try to focus today on these three things for the automation solutions. Is the green hydrogen production, so what really goes in the electrolyzer. Second is the natural gas pipeline, where you are trying to blend the hydrogen in the natural gas. In that situation, what are the automation requirements which customer will have? And of course, when it comes to mobility, these are the three areas we will just try to briefly, because the time is limited, try to see. So when we talk about the hydrogen production, this is the typical P&ID for any electrolyzer. So let's look at very quickly what are the different instruments Immersion has which exactly suits or tailored for those kind of applications. For example, the vortex flow meters, because typically the hydrogen gas which is produced out of electrolyzer directly, they are at a very, very low pressure. And for such applications, you need the flow meter which will have as less as possible the pressure drop. And our vortex is the best solution for this. It is designed specifically, as we have seen, that the hydrogen can really diffuse through the metal, it can embrittle the metal. Similarly, in the vortex also, it can diffuse and go to the piezoelectric sensor and can destroy the sensor quickly. So there are certain design aspects which are taken care in our vortex flow meter for adopting it for the hydrogen applications. The compact orifice, again for the flow measurement. Then it is the control valve is basically the Fisher control valve what we have. Various ASCO valves. Then the Aventix valve island which goes in these applications. Pressure transmitters specifically, which with a diaphragm which is gold plated, because hydrogen should not diffuse through the diaphragm, so that is why it is gold plated for beyond certain pressure and temperatures. Then TESCOM back pressure regulators, then ASCO, again valves of ASCO, then the control system, it is a delta V control system, or if you need simple controllers, then it is H controllers what we have, which are tailored to these applications. And then temperature measurements, and then radar in these kind of applications. The analyzer, when you produce the hydrogen, how much is the hydrogen concentration after producing, what are the impurities in these hydrogens. So both the percentage measurement of hydrogen or the impurity measurement in the hydrogen stream. So those analyzers what we have, which goes in these applications. Conductivity when it comes to the water quality, because when you feed the water in the electrolyzer, it has to have certain quality. So for those purpose, the pH conductivity, dissolved oxygen, or suspended solid particulate meters, all those gamut of field instruments or analyzers what we have. Now let's talk about the gas blending in the, when you try to blend the hydrogen in the pipeline. Now today we are trying to see blending of 5% hydrogen, but the aim is that we are trying to go up to 20% of hydrogen blending in the pipeline. So what are the different instruments which goes? Of course, the Coriolis flow meters, the flow measurement basically for the hydrogen line, and the flow measurement for the overall natural gas pipelines, the gas chromatograph which goes for measuring the gas quality. And of course, being hydrogen, you need the safety instrumentation, that is the gas detectors, flame detectors, and leak detectors. So these are all instruments which we have for these kind of applications. When we talk about the refueling applications, just look at the TESCOM regulator. It is one of the very, very popular regulator which goes in any dispensing kind of applications, and it can go up to 15,000 psi, because it typically the dispenser dispenses requirement is at least 700 bar, so that you get sufficient energy filled in that particular tank. So 700 bar 3 minutes filling with is possible with using these kind of regulators. Then of course, which comes is the most critical item, which is the Coriolis flow meter, because your money transfer or billing is going to happen based on the Coriolis flow meter. Again, this is a specialized flow meter for that kind of high applications, high pressure applications. And hydrogen, mass wise, it is the lightest component. So this is a mass flow meter. So even with the low mass, how with this design you can get the better accuracy or highest accuracy possible. Then for the safety purpose, the flame detectors and the ultrasonic leak detector, where you can use it as for the safety applications, and then the gateway controllers. Some of the, we have done a lot of projects we have contributed. For example, in Canada, we have given the system field instrumentations for the PEM type of electrolyzer, field instruments, analyzers, valves, and solenoids. Belgium, whatever hydrogen pilot project happened, in that also we have given field instruments, analyzers. In India, you can see steam methane reformer, where HCNG is the project where we have given our various field instruments and the flow instruments. So these are some of the references what we have. So wherever you are in the hydrogen value chain, whether you are in the designing, whether you are a consultant, or you are a manufacturer, or you are an EPC, or you are operating the plant, everywhere we can become your credible partner in this journey by offering our products, services, and expertise. Thank you.
I'll request Mr. Butala to come up stage and give it. क्या हेलो आवाज नहीं आ हेलो हाँ और 3 बजे पहुँच जाएंगे तो ओहो यहाँ तो 4:30 का प्रोग्राम करा दिया क्योंकि वो जो Thank you, Rajan. Thank you so much. Now we have Mr. Gautam Samanta, Head PV Technology, Juniper Green Energy Private Limited. He will be given Heikel's Chemcon Distinguished Speaker Award, and he will speak on the occasion of the renewable energy. Come.
No, no, it's okay.
Already uploaded?
Yeah,
Which one?
the first one. Good morning, everybody, and I will try to introduce myself. My name is Gautam Samanta, working in Juniper Green Energy, and we have a partner with the Roofshall. Mr. Dipankar Pal is our director, as well as Nilesh Mahajan. So Roofshall is APC company, and they are ranking 5th in India, and so far the business are expanding in the.
I can introduce you first, and then you can introduce Roofshall.
Okay.
Gautam Samanta, he is representing the Juniper Green Energy, the moment working with in association of Roofshall Energy. He basically appointed as principal investigators by Quality Council of India, Ministry of Commerce and Industry, Government of India, in STARS Research Scheme Association under Indian Institute of Science, Bangalore, and Ministry of Education. More than 36 years of professional experience, including last 29 years in international solar photovoltaic industries. Now you can go on and please.
Yes, thank you. So we have a partner with Roofshall. So Roofshall is one of the 5th EPC company in India, and Mr. Dipankar Pal is our director, and Mr. Nilesh Mahajan is also our director. So we have done a lot of installations in India, and especially in the remote area, in the tea garden, somewhere in the northeastern states, and there are several opportunity, for outside India, so the new horizon now we have. So I will start with the presentations of the hydrogen fuel for the future. Okay, the table of content includes the global energy scenario, the renewable energy scenario in India, then what is that LCOE and LCOS comparison, then energy storage technology, introduction of the potential of hydrogen as well, applications and the production of hydrogen, green hydrogen, type of electrolyzers, integration, storage and the transportations, way forward and conclusion. I think Rajanji has already covered a lot of things on the green hydrogen, but let us go through the presentation. So if you look at the global energy scenario, on the left side, if we see that the electricity is the major contribution, and the way it is growing by 2050, it will take a huge volume of these things in the terawatt level, And if you see in the middle of this graph, right, where solar and wind will take a major chunk of this whole share of this energy and the electricity, right? And the roadmap by 2050 is that something like more than 6 terawatt of the solar will be taking the share, and on the wind side also it will be almost in excess of the 5 terawatt. And the global electricity, in terms of the percentage, as I told you, and the renewable energy will be a share of 85%, and a majority will be coming from these two, solar and wind as well. All right. If you see in the Indian scenario, right, we have already completed nearly 120 gigawatt, and out of which the 60 gigawatt is a solar, and the wind side is almost closer to 48 gigawatt. But India government has a target of 500 gigawatt in the renewable energy capacity, and if we see that the renewable energy, the share should be more than 50%, right? So there is a new business segment that the increasing in the coal prices, the current volatility, and the large industries are investing heavily in the renewable energy. So the new demand is also emerging on the big way on the green fuel productions, green hydrogen basically, right? And the CNI sector, in fact, the Rupsal is also working on a lot of things in the CNI sectors. Is gaining a very strong momentum, the solar and the wind and the critical with the high PLF. The reason in the CNI sector is that the electricity cost as on date is very high. So if you do the solar, it is almost like 50% of the whole cost, right? So there are different enablers for the hybrid energy growth, something like that, the solar wind. And then the RTC round the clock are also preferred utility projects with the higher PLF and the scheduled power. In the renewable energy scenario, as I told you, India ranked 4th globally, and including the large hydro, and wind is also in the 4th rank globally. A total of 172.72 gigawatt of the capacity which has been installed in India, and this is including on the large hydro 46.85, and wind and solar and the biomass itself is 119.0 and almost 120 gigawatt, right? And the nuclear is 6.78. But the generation's capacity for the non-fossil fuel is 42.26 of the total installed capacity, right? So if you look into the total installation this year is almost 14.21 gigawatt in the renewable energy compared to 11.9 gigawatt of the last year, 2021. So these pictures on the left side is a solar installations, these are all on the utility scale. On the bottom is that solar and the wind hybrid. And on the right hand side, this is the wind, how it is working in the different locations in India, particularly in the coastal area. And on the right hand side, on the bottom is that the combinations of the RTC round the clock, the solar, wind, and the energy storage. So if you look at the formula on the LCOE, the levelized cost of electricity, so it is nothing but the total cost divided by the total power generations. So total investment is that initial capex that we initially go with that, and then the operation and the maintenance sides, right? So if you look at the capex and the utility scale sectors, right, the capex is very high because on the solar side, we installed, say for example, if it is a 100 megawatt project, and depending on the locations, there is overloading of nowadays is around 40 to 45%. So therefore, the capex goes 1.4 times over there, and then on the operations and maintenance sides, what you do today. Earlier it was water-based cleaning, but which is called the wet cleaning. Nowadays it is a dry cleaning. That means a lot of robotics are also working over there. So we are not only saving the Mother Earth, right, the less consumptions on the water, but also with the kind of robotic cleaning. In fact, this robotic cleaning has got another kind of a solar module. The power is not taking from the systems. They have got their own power systems. On the bottom side, if you see the total generations, the generations on the solar depends upon on the as you know today that solar modules are high wattage modules and the high efficiency module. The power density is more. That means we get today like 540 to 550 watt modules with a 2.55 square meter area, So the high power, number one. Number two is the high reliability. If you look at the today's monopark modules, which is available, they are not only on the first year, but also subsequent year. First year is less than 2% degradations, and subsequent year is 0.45, or 0.4, depending on whether it is a bifacial module, glass module, or maybe monofacial module. So the high power generations and also the lowest. So the bottom side, the denominator plays a big role on the power generations, right? So if you look at the LCOE comparisons, if we see that the thin film is always preferable, but if you look in the today's availability of the modules in the solar side, right? Earlier, amorphous silicon was one of the major area, but because of the low efficiency, still they don't have the market. One more technology is called the CIGS, which is very popular. And if you know that in Japan, there's a Solar Frontier. There's a company called Solar Frontier. It's very, very popular, and their generations is much, much higher. And there is one more company is called the First Solar. They are also cadmium telluride based. So that is also there. So they have the lowest, in terms of the LCOE, but at the same time, the crystalline silicon has also very closer to that one, right? So if you look at the crystalline silicon, now the monopark technology P-type is very dominant, but way forward, there is a mass productions of the N-type material, which is TOPCon and the HGT, so these is not only coming in terms of the higher, in terms of the power density, but also in terms of the reliability on the long-term degradations are much, much lower. So effectively, you get a better LCOE, right? So this is a kind of comparisons with the conventional renewable energy versus the conventional. Conventional is obviously the gas-based as well as the coal-based. They're relatively cheaper, but they're not as cheaper with the renewable energy, So if you look at the LCOE comparisons here, and we see that there is a kind of a the subsidy driven on the offshore as well as the onshore wind. So offshore wind is a thing where that will be in popular. In future, there are a couple of projects are coming up in Tamil Nadu that these offshore project has a higher PLF, and the wind is a little bit unpredictable in certain area, but in case of a offshore project, this will be getting a PLF of more than 60%, that will be very, very competitive. Yeah. So LCA comparisons of wind versus solar, they are very, very close, but there is a margin like, from $26 to $50 on the bottom side on the wind, and then on the solar side is a 30 versus 41. But I believe on the way forwards by 2000, maybe another 2 to 3 years time, the solar will be much, much cheaper than these things, wind as well. And so there is a huge growth opportunity in the solar, right? So there is a LCOS comparisons with the dollars versus kilowatt per year, and if you see that for 100 megawatt project, that with the 100 megawatt hour, so this depend on the how much storage that you were putting up in your project. So according to that, there is a cost comparisons, and then with the 100 megawatt hour is the cheapest. If you do a 200 megawatt hour, the costs are more. So depending on the kind of installations, how much you want to have a ratio in terms of the project versus total installed capacity versus your storage capacity. So LCOE comparisons here is a dollar per megawatt hour. So here the comparisons are a bit different than the earlier one. So even we could see that the 100 megawatt installations with the 200 megawatt hour is a kind of a storage, and then with the 400 megawatt storage is a cheaper one, right? But there are different applications on the whole PV and the storage side. I'll go into the technology side, and it will be very clear in that. here, the energy storage technology. If you look at the whole horizons of the energy storage, whether I want to store it for kilowatt or megawatt hour or gigawatt hour. So on the left side, if we see that the capacitors and the superconducting coil, these are all very, I think, low storage in terms of the kilowatt hour. But there are some old technologies like batteries, which is the lead acid batteries, which are very popular in the low cost. But in terms of the storage, it's very, very, comparatively it is low, and also you have to maintain a lot of things. Lithium ion is also there, and the redox flow. I'll go each of these things in the details. And then there is a pump hydro, which is very popular and is the old technology. I mean, most of the things are the old technology as installed in Japan, and a couple of things in the West Bengal, and now you might be knowing that Greenco is coming up with the 4 gigawatt level of the pump hydro technology. And then there is a compressed air as well. And if you look at the hydrogen, it's a very, very wide, from 1 megawatt to 1 terawatt. And we'll go into the hydrogen as well, now. So this is the kind of thing, from the mechanical side, in the pump hydro, then compressed air, then the flywheel, depending on the kind of the storage applications. Then the electrochemicals mean the secondary batteries, the lead acid, and then nickel cadmiums, and then lithium as well. There's a flow batteries as well. On the chemical side, definitely the hydrogen and the electrolyzers and the fuel cell. We'll go with the details on that. On the electrical side, double layered and the capacitors, superconducting magnet. On the thermal side, sensible heat storage. Now on the mechanical energy storage side, pump hydro, as I told you, this is a very high capex, and also it takes about 24 months to 36 months, in 2 to 3 years time, right? So there is a company, as I told you, the Greenco, they are coming up with a big such a project. And in West Bengal, there is a project, that one. The compressed air is also an old technology. Flywheel is a technology where is not very popular, but advanced lead acid batteries. So when we make this kind of a storage system, so there is a lot of things that in the design side you have to look into. Say, for example, how much is the energy density on that, what will be, how many charging the discharging cycle, that one, and what will be the DOD, depth of the discharge, So if you look that one, then lead acid batteries also, is good, efficient, 80 to 85%, but lithium ion battery is a 90 to 95%, I'm in the best in class, but flow batteries is around 60 to 70% on that, So double layer capacitors, then the superconducting magnet on the low this thing storage application side capacity, and then we have a thermal storage, thermochemical, and the sensible heat and the latent heat side. Chemical storage sides, definitely the hydrogen is the things, is the electrolyzers. With the electrolysis system, this is very old and very popular, and the hydrogen electrolyzers, how it is breaking the water into the hydrogen, the oxygen. So we'll go into the detail on that. So introductions of the hydrogen. Hydrogen is a very extremely versatile, but it's a very simple and most abundant, and it's available in the molecule, maybe 90% on the earth. And hydrogen is an energy carrier, not the source of the energy, right? Hydrogen in nature, mostly it is combined with other element, right? Most of the hydrogen is used today is generated via method of different steam method reforming, and we'll go into the detail on that one, under the pressure and the generating hydrogen and the carbon, summary, the carbon dioxide and the carbon monoxide as well, In the subsequent operations, there are different applications as well, So we'll go on that one. There is a huge potential of the hydrogen, the building up the early technology deployment. So hydrogen is not a new technology; it's very, very old. In addition, there are different applications moving with the different kind of a pilot project and deployment. Basically, our objective is to go for a green hydrogen. We will go for that one. So hydrogen, the applications in the today's economy, right? There is a in the power side, gas distributions, oil and the gas productions, the heavy specialty industries, industrial chemical productions, and the heavy duty and the industrial vehicles, the cargo and the passenger rail, and then the marine and the shipping side, aviations and the light duty vehicles and the others, right? So this has already been discussed, like the how to produce the gray hydrogen, the blue hydrogen, the yellow hydrogen, and the green hydrogen. So if we wake from the fossil fuel and with the steam methane, and then there are two components. One is that the carbon dioxide and the gray hydrogen, right? And in the same fossil fuel, if you break these things, and then we get a carbon monoxide and the blue hydrogen. But you have to see that as we are going in a decarbonizing phase, that means how to reduce the carbon component, right? And the carbon as an element, right? So in the nuclear also, what you do actually through the chemical splitting, we are producing oxygens and the yellow hydrogen. But here, this is a kind of a thing where we have to see that with the high temperature process and with the high current and the high temperatures, how the yellow hydrogen and the oxygens is to be used in our applications, right? But in the renewable side, if we see that the water, the H2O, which is a low temperature process, and we get a oxygen as well as the green hydrogen. But here, this water, you have to see that normal water has got a lot of contaminations with the heavy metals. This water is a demineralized water or deionized water. So these deionized waters, and I think those who are working in the fab, particularly in the semiconductor industry, so you might be knowing that there are several processes of the chemical method. Initially you have to remove the different, the contaminations, and then after that through a ion exchange technique. So you have a minimum the metals, then there is a cation and anion, and so that we have a resistivity of maybe 16 to 18 megaohm. Then that water will be utilized as a pure H2O, which is less you can say the contaminations on that, and then you have to split it. So the green hydrogen here from the renewable, if you see that in the electrolyzers, this process is very, very old, but here how it is splitting the oxygen and the hydrogen. So hydrogen definitely is on the negative side, and oxygen is on the positive side. But the storage of hydrogen is very, very important. Rajanji has already told that this hydrogen storage is, from the safety point of view, is very, very important. I have worked in the factory, and I'm also working where we have used the hydrogen in the PECVD department, plasma enhanced chemical vapor deposition. If you look into the hydrogen, there are three different pipes. So inner pipe is taking the hydrogen, and then there is a next layer is a kind of the vacuum, and one more, the outer pipe is also for the safety and all. So what I want to mean, if this hydrogen by any chance come into the contact by air, so this is like a hydrogen bomb. This is blown like within few seconds. So you have to be very careful that how you are handling this hydrogen from the safety point of view, right? So applications is on. So whether it can be the hydrogen can be as a gaseous form, or how it has to be stored, those are very, very important factors, right? So if you look at the fertilizer sectors, like there are urea we are using, and then there is a diammonia phosphate and the complex fertilizers. So as on date, so the production capacity in India is from 43 to 73. This is a kind of a million metric ton of capacity, and which will be used by 2035. So we have a huge capacity of the ammonia as well, right? So we have to look into the levelized cost of the hydrogen. So how to get that one? The first of all, the generations of the power and the supply, I think, throughout and a very stable grid. So that means from the metallurgical requirement of the electrolyzers and the hydrogen networks and the fire detection systems, the water, the chemicals, if any source, and the quality, quantity has to be very defined, requirement of hydrogen storage facility and the transportation systems, hydrogen leakage detections and the protection systems. Second thing is that this is the major component where the hydrogen plant and mainly with the electrolyzers, you have to have a plan on that. And third is that the selections of the each and every component in such a way that it should be commercially evaluated, and then the BOQ, what is the kind of the area requirement of the assessment, the layout of the whole finalization, that the technical specifications, the major equipment, and then the hydrogen production estimations and the simulation to evaluate the losses and the degradations pattern for each technology. The fifth one is that the OPEX and the cost and the other one, and sixth is the quality assurance. So the quality assurance has to be 100% in a sense, like, there is no such chance. From the design aspect point of view, we have to be very, very careful on that, to have achieve on that. So there are four different type of electrolyzers, the alkali based, then the polymer based, then the advanced polymer based, and the solid oxide fuel. So if you look at the whole parameter side, on the efficiency side, definitely the polymer based are also equally with the alkaline 50 to 55%, but solid oxide fuel 35 to 40%. If you look at the cost, definitely the polymer side is higher, alkaline is the best choice, and then solid oxide fuel also is very high. The cost of the BOP is also on the polymer side higher, alkaline is the lowest, and then the solid oxide fuel is the highest. On the implementation side, the polymer base is also high, this alkali is also high, but solid oxide fuel is very, very low. Reduce expectations in terms of the cost. As we know, the alkali is already mature technology. There is a lot of scope that on the polymer base as well as solid oxide fuel has to be there, right? If you look at an overview of the electrolyzers plant, on the left side, if you see that, as I told you, this producings of this hydrogen and the oxygen and how to handle it into the pipeline. This is a clear, the flow chart in the diagram, but this configuration is a very generic system and may not be representative for all manufacturers. And it depends on the kind of the design as well, how to handle oxygen and how to handle, hydrogen on the post-production, right? And the water quality, as I told you, is a very, very high quality demineralized water. Okay, the electrolyzer target with the green hydrogen, if we look into on the left-hand side, this is the gigawatt level of the electrolyzer capacity versus the million tons of hydrogen production. Here, if you see that 1 million ton of the green hydrogen productions, which takes around 11 to 13 gigawatt of electrolyzer capacity. So that means if we have somewhere around 12 and a half level of the million tons of the hydrogen production, then what you need a kind of the electrolyzer 160 gigawatt of the electrolyzers capacity. This is a huge one. So we have to plan accordingly for this kind of a productions, right? So integration side, we have to have a technology expert, the financial analysis, engineering and procurement, then licensings, the operations and the maintenance and the integrations of the whole. Integration of the industries, I think Rajanji has already mentioned over here, but you have to have input of the what is a renewable energy mix with the LCOE, minimum LCOE definitely. In the balance of the system, the hydrogen processing unit, control systems, auxiliary equipment and all, electrolyzers, the capacity, how to do the capex, efficiency, the life cycle requirement, transportations in the conventional cost, transportation cost, what are the losses and what are the kind of the conversion cost, the risk and the hazards. On the end user side, the outlook, the demand scenario, market sizing, technology readiness, and the support in the ecosystems, right? If you look at the storage of the overall systems here in the current scenario, that hydrogen is stored and delivered in the compressed gas or the liquid, But in the future, if you have to have such a high volume hydrogen to be to be handled, then the volume is a very, very critical. The distance, how much it will be traveled, what will be the kind of the cost is a red. You have to be very, very careful, and who will be using that end user, So local guidelines and the regulations of the either from the government, and the locations where it has to be, how much it has to be distance to be traveled, and what is the volume, the scale, and the technology advancement in the liquefations as well, and the recovery of the hydrogen. These are very, very important factors. So all these parameters are very, very important to have a proper engineering before designing the kind of systems. So these are the green hydrogen roadmap. How it is going, and then this has been taken from the the IRENA. So if you look at there is a huge future by 2050, and if you see that with the alkaline electrolyzers, the cost reductions are very, very very attractive as well. But in the polymer side, it needs to take into the technology side. On the right side is a kind of the blue, and the green hydrogen is a kind of a roadmap as on date. This is not very, very cost effective as all. So way forward, what is need to be done to the integration side? First of all, integrations of the potential linkage between the sources of the supply and the demand of the hydrogen in the energy scenario, understanding of the infrastructure which is needs, the standards and the knowledge of the development, the development of the different codes, standards, of the manuals, the policies, the technologies, and the data on the cost trend, the knowledge sharing, the creations on the focus of the knowledge exchange together with all the key stakeholders, and the effective the partnerships between all those who can provide the fund which can be installed the plant and the manage the safety, right? The observation in all the places with the water stress, and the sources of the water of the hydrogen production shall be explicitly considered in the strategic, in the elaborated the project planning. So that means in the today dedicated hydrogen productions, already 70 to 80 metric ton of the hydrogens are to be produced with the electrolysis, and this will be resulting in the water demand of the 607 million cubic meters. You understand, somebody will not take into the consideration that what will be kind of the water in volume and the quality as well. That kind of a, you should have a plan. So future in the hydrogen side, there is 1 or 2 minutes. I'll go very quickly on that. A lot of things has been taken from these things. The green hydrogen, where in the LCOA cost side is very, very high as on date. Not only on the capex side, but also in the other operating costs. So natural. The gas-based hydrogens are in a better these things, but coal-based hydrogens is also. But these hydrogen are not our objective. We have to work with the green hydrogen, right? The current RE-based scenario where all this calculated has been done with the RTC round the clock, right? 3 rupees 60 paise is a tariff on the based on that, And there is electrolyzer cost is also varying $500 to 969 per kilowatt hour. So if you look at this whole scenario, right, and today and with the aggregated these things, the hydrogen pricing, so it is $5.3 to $5.9, is a per kg, This is a projected cost of the already that's on, and the green hydrogen, the trajectory. So initially the standalone solar has got a, is a limited, the cost is very high, is 3.2 to $3. But if we go in the RTC kind of a mode, and then by 2030 it may be $1.43, per kg, and this is the kind of a hydrogen demand scenario. But with all these things, if we see in here on the right hand side, the high cost and the high impact side, and on the left hand side, the high cost and the low impact, with the methanol, this is the ammonia, and but the HDV is a low cost and the low impact. But the low cost and the high impact with the refineries, right? So this is the kind of a scenario by 2030 or 2040, right? Okay, the potential for the electrolyzers market here is a very, very huge potential from 2030 to 2050, 20 gigawatt, versus, 226. So this is the kind of the cost breakup of the electrolyzers. So there is a time constraint. So I'll go directly, the cost breakup. If somebody is interested, I can show what is the kind of a roadmap and what are the different kind of a cost breakup out there. So directly I'll go to the conclusion. So most of the competitiveness of the green hydrogen with respect to the high volume manufacturing capacity of the, so basically, you know, everything we have to do in a volume means high volume manufacturing of the electrolyzers. Next thing is that the electrolyzer technology, whether we will go for the alkaline based or the polymer based, definitely we need that, you know, it should be polymer based or maybe, you know, solid oxide fuel with a kind of the cost reductions and a quick turnaround time. And the third thing is that the electrolyzer stack, which is comprising of 32 to 40% of the whole capex, and where electricity cost is also 30 to 60%, you know, with the LCOH. So we have to have, you know, between these two, you know, whether it has a electrolyzer capex. So the best thing will be like we will have a preferred the low cost of the electricity. Next is the policy actions. You know, we see that the carbon prices are the incentives, you know, that will also influence on the green hydrogen side, right? The future of the competitiveness of the green hydrogen depends upon mostly on the proximity of the productions, then within the turn from the transportation storage. So it has to be very, very closer to the, you know, the power plant, you know, I mean, all the facility has to be there. And the cost of the electricity is a very, very is a critical factor, and which should be as low as possible. You know, in such scenario, you know, success will achieve. You know, when there is a high volume, I mean, the green hydrogen in this scale with the abundant, low or the zero cost or the cartel renewable energy. But how to do that one? You know, if we do our, you know, either wind or the solar systems, you know, there is a kind called overloading, right? So from 11 o'clock to 3 o'clock, there is an excess generations, you know. If we send this excess generation of electricity to the, you know, in the green hydrogen productions with the electrolyzers, you know, that is the things, you know, I want to mention that, you know, what do we do? This is a wastage of energy. We have a, you know, our tripping our systems, you know, in our inverters, so that we don't allow the excess power to the grid, you know. So in that particular, you know, 11 to maybe 3 o'clock, 4 hours, you know, which can be, I mean, the power which is already free power, I will say, so that can be fed to the green hydrogen. And this will be kind of a future policy as well, you know. I mean, we can do a lot of initiative that one, and I know all the developers in India as well as in the abroad, they are working on that particular objectives. So my final thing is that we need to work jointly together to achieve the better levelized cost of electricity or the storage or the hydrogen with the better IRR. Thank you very much.
Thank you, Mr. Samanta, for an excellent speech.
Thank you.
So we have the next speaker, Mr. Alok Pandit. Mr. Pandit will be speaking for Sartorius India's Chemcon Distinguished Speaker Award. Mr. Pandit is the Chief Executive Officer of Equinox Software Services, Pune. He brings over 35 years of experience in plant operations, particularly petroleum refinery, MES, process simulation, LP modeling, and industrial process optimization. A chemical process engineer, Alok learned the craft of Hinditron and Onward technologies. Later, Alok led and managed process software division at Onward with agency of Setpoint and Aspen Tech. Alok coordinated all business management tasks for setting up the OTS team at Onward. Those experiences, management tasks for setting up OTS team, those experiences underscored intense challenges, bringing his entrepreneurial mindset together to improve the overall profitability of the process group at Onward. Consequently, in 2000, Alok founded Hyprotech India at Pune as a 100% subsidiary of Hyprotech Canada and managed it efficiently until it was acquired by Aspen Tech in 2002. Post-acquisition, Alok was retained at the head of the business for South Asia by Aspen Tech, further growing to the role of Vice President responsible for Southeast Asia, Australia, and New Zealand, apart from SAARC region. Alok is also the chairman of Indian Institute of Chemical Engineers, Pune region. Alok, for your floor, please.
Thank you very much. Just give me a couple of minutes. Okay, we can connect now. कर रहा हूँ.
ये फर्स्ट स्लाइड में
Okay, good morning and welcome to this session. I would like to thank ISHE, HBTI, the regional chapter, Kanpur regional chapter, for giving me this opportunity to talk to you today on this very interesting area of performance management or performance analytics in chemical process plants. Two of my earlier speakers spoke on alternative energy and both of them spoke about hydrogen. So I'm going to take this discussion to altogether a different direction, but I hope you will enjoy this presentation. What I would like to cover is briefly talk about Equinox in 1 or 2 slides and then get to the topic of the day, which is data, how data is generated, how are we handling the data, and finally how data is used for performance analysis. And I'll try to give 1 or 2 examples or 3 examples depending on the time on how we used in data analysis in some of the projects. Equinox is a young company, just about 15-year-old. 5 of us set up in 2007. And it is basically providing what I call IT-enabled chemical engineering consulting services to the Indian and global process industry. We have delivered projects in multiple countries. I guess more than 200 projects now in about 20 countries. So that's how Equinox is working, and it is based out of Pune with about 75 chemical engineers working for Equinox. I will skip some of these slides and come directly to the topic. I think that is more important. Okay, so let's come to data. I would like to give all of you an assignment. When you go back, please think it over and give me a call and tell me what is data called in your language. Whether it is Hindi, Gujarati, Marathi, Bengali, whether there is an equivalent word for data in your language. I would like to know, because I'm doing some research on this. Today, obviously we don't have time to discuss that part, but it's a very, very interesting part, that what do we call data in our native language. Okay. Data, a lot of people have talked about data. Mukesh Ambani once said that data is the new oil. Infosys says that in data we trust, in God we trust, everyone else should bring data. So, I mean, data is very important for decision making. Notice that over last couple of years, so much talk is happening around data. It's almost become like, you know, talk of the town or talk of the day, right? The number of publications that are appearing about big data is exponentially growing, right? So, in chemical engineering or chemical industry, what is this data that we are talking about, and what is the kind of size of data that we are talking about, right? So I have tried to give some examples from various industry segments, and you can see that we are talking of terabytes of data, right? Terabytes of data per day, and if you convert that data to almost like annual basis, we are talking of petabytes of data, right? So this is really huge amount of data. Anybody who is interested in finding out how this data size is calculated, we can meet after this lecture and talk about it. What is the kind of data that chemical engineers talk about? The simplest is obviously what we call is scalar data, which is like point data. So it could be temperature at one location, flow at one location, pressure at one location. Then we talk about vector data or array data, right? So for example, compositions, which will be like 8, 9, 10 components of your stream, and mole fractions, mass fractions of those. Profiles like temperature profile in a distillation column, and so on. So chemical engineers deal with all kind of data. I mean, there is huge variety of data that we are encountering. This is an example of where this kind of applications and what is the kind of size of data that they are generating. So it's starting from digital twin, process digital twin, going to dynamic models, going to the plant digital twin, or integrated models where you have a plant with environment. You can see that what kind of huge amount of data that is being generated by the chemical industry. This data that we are talking about has got various characteristics, and there are 3 important characteristics that I want to highlight, and there is a 4th one which is more like emerging characteristic of this big data. So first one obviously is the volume. We are talking of really huge volume of data. The second is the variety of data. We talked about scalar data, profile data, vector data, multimedia data, audio, email, text, logbooks, you know, all kind of data. So that is a variety of data. And then the velocity of data. The data comes at a pretty high speed. If you look at a DCS system, I mean, the scan rate could be 100 milliseconds or 200 milliseconds, right? So we are generating 4 to 10 kind of samples every second. And remember that data that is coming in real time. So the data, when it reaches me, it is real time at this point of time. If I don't take a decision, this data is history. The very next second, it is history, right? So it is historized. So I have to take decision so fast, right? And then the last characteristic of this data is that people say that all data is not generated equal. There are some data which are more reliable, so more trustworthy, and some data which are not trustworthy. So similarly, chemical engineers have to differentiate or discriminate between the quality of data that is coming in, and based on that take a final decision. So question is that why today suddenly this data analytics, performance analysis, artificial intelligence, IoT, machine learning, you name it. I mean, why all these things have become so popular like last maybe 3 to 5 years time, right? I would like to point you to a presentation made by Professor Venkata Subramaniam in one of the AICHE meetings. He talked about what are the challenges, and he was talking about the lack of computational power, lack of storage or cheaper storage, lack of communication, basically the data to be communicated from plant to a central control system, and of course lack of data itself is a challenge. So he says that so many costs or so many factors were prohibitive, which was not allowing us to do this data analytics in real time. Incidentally, he also gave an excellent example of how the computing power is coming down. So in 1985, when India bought the first supercomputer for meteorological department in New Delhi, that was a Cray supercomputer, you can see the cost of that supercomputer versus its power, and the cost of a computer today and the power of a computer today. I mean, there is a tremendous amount of reduction in cost per unit of computing power. I will come back to this point little later. If you look at my machine right now in front of me, which is a Dell machine, a PC machine, which is having a Core i7 processor. This machine, which costs probably about 50,000, 60,000 rupees, is having a compute power of almost 211 gigaflops. You can go back to the Intel website and look at the compute power of your own machine, right? So this is almost 211 gigaflops. Compare this compute power of my laptop with the Cray 2 supercomputer in 1985 was only 1.9 gigaflop computing power, and it was costing probably millions of dollars. So the compute power has become really, really cheap, right? It is very easily available to all of us. So that is point number one. Point number two is the storage capacity. This is an excellent comparison. Like if I take the storage cost of data in gigabytes, US dollar per gigabyte, in 1995, if that cost was almost equal to Empire State Building, today that cost is equivalent to like a almond. So you can see how much reduction in cost has happened. Similarly, the cost of transmission of data. We all know that the mobile costs have come down, the communication costs have come down, the internet costs have come down, and you can see this is of course the US data, how much reduction has happened. But even in India, the cost of transferring 1 gigabyte of data used to be almost 269 rupees in 2014. Today it is hardly 9 rupees. In fact, it has probably come down further because this is 2021 cost. So now we know that computing is not a problem, storage is not a problem, communication is not a problem. So the only issue is that how do we analyze this data and from where this data is coming, right? So obviously the data is coming from the plant. Plant has got a lot of instruments, lot of sensors, and those are sending data in real time. That data needs to be stored, analyzed, and an action has to be taken. Otherwise, there is no point in taking data and just storing it on your hard disk if we do not analyze and take action on that, right? Oh, these are some publications. I think I will skip talking about them. Let's talk to what do we do with this data. As I said, if we simply store data, then no big fun, right? It will become history the second, 1 second later, right? So data is used to do various kind of analytics, right? Most of you would be aware about these 3 type of analytics. I will skip this in the interest of time, but I want to highlight one important point. Typically, when people look at data in chemical plants, or operators are looking at, or engineers are looking at data, we are talking of real-time time series data, right? It is a data as a function of time. So you can see temperature trend, you can see pressure trend, you can see property trend, quality trend. So these are like on x-axis I'm plotting the time axis, and on the y-axis I'm plotting the parameter of interest. Interesting point is that when you look at a data from this perspective, this is like a scalar perspective, right? Only one variable at a time is what you are looking at. It gives you some information, but unfortunately it hides a lot of information. I'll give you a simple example. If I plot these 2 graphs on one single graph, right? Today I have plotted pH as a function of time, as well as temperature as a function of time. But if I plot temperature on one axis and pH on another axis, so these are the 2 parameters that I was interested in monitoring. The moment I do that, I see altogether a different picture. I can very easily see now that there is a cluster of points which are very closely populated, but there is one point which is almost like an outlier, right? You can see that red point here. Very easily you will be able to, visibly the operator will be able to see and say that plant has gone wrong or the process has gone wrong. But if you look at this previous chart, there is no way somebody can discriminate what is happening to this process, because that red point is just another point in the huge amount of data that is streaming in at any given point of time. And that's why it is important for us to look at proper visualization and proper analytical techniques to take decisions in real time. This is an example of distillation column where we are having almost like 60, 70, 80 parameters coming in from the plant at a given point of time. Again, question, how do we know that this data is correct? How do we decide what operating conditions to change in the column? Take this example. Can someone tell me what is wrong in this data that I show you on the screen? So I'm showing you 124 kgs per hour of feed entering a distillation column, and there are 2 more flow meters, one at the top distillate at bottom, which are adding up to 64 plus 58, which is 122. So I have 124 kgs going in and 122 coming out at a steady state of this system, which obviously is not possible. Question is that one of these flow meters is wrong, or all of these flow meters are wrong. And if I want to find out which flow meter is wrong, because I need to take a decision whether this is the right quality of product or right throughput or right yield of this distillation column, it's a real challenge. I need to have a really good analytical techniques implemented on top of the control system data that is flowing in. There is a branch of engineering called chemometrics. You can go back and look at Wikipedia, which talks about various techniques that are used in data analytics by chemical engineers. So when this data is coming, how do we do this performance analysis? Obviously, I say that performance analysis of a chemical plant requires huge amount of data. The more the data, the better it is. Chemical engineers are very happy to see large amount of data, historical data plus the real-time data, right? Both type of data is what I need. Data obviously, as I said, is coming from sensors, wireless or wired sensors, nowadays mostly wireless. Large data storage, I think not an issue. Ability to handle inaccuracy in the data or noise in the data. Like I showed you, mass in is not equal to mass out, so some flow meter is wrong. Need obviously fast computing to do the speedy analysis, and of course efficient programming languages, which you and me may not require, but people who are developing those applications will require. And I require an inferential engine which should be able to look at this data, streaming data, and tell me that this kind of pattern is emerging from the plant, and therefore this could be the state of the plant, or this could be the next state of the plant. Like I can predict what is likely to happen, slightly down the line. These are various techniques that are used in data analytics. I will skip that. AI or AI-enabled tools, again, there are many which are being used. I will skip that. I'm not going to spend time. Artificial neural network is another method, or one of the methods. Okay, so I will come to now couple of applications where this data analytics is used. I have listed a few here, and fortunately, as a company, Equinox, I think, has delivered probably all of them in some project or the other. I have taken 3 examples. I want to show you an example from a continuous plant. Obviously, I am not naming the client or the site, but I would like to certainly give you a glimpse of the data. So look at this data. This is last 3-year production data of this plant. Sorry. I press something. कुछ प्रेस हो गया क्या? यहाँ से कुछ प्रेस हो.
यहाँ से ब्लैंक हो गया. इससे ब्लैंक होता है.
It will go only in presentation mode, kya? I was opening another file.
Go to desktop.
Yes.
Which file? Just wait.
Okay, you just wait. I will go back to the presentation. Okay, just wanted to give you a glimpse of this data. This is almost like more than 3-year data from a plant, which shows the daily production report on the plant side, as well as the daily production report on the CPP side. So it talks about, it gives you the energy supplier side, as well as the energy consumption side of this plant. Okay, let's go back to, yeah. All right, so we are looking at almost like 1,000 plus rows of data and almost 100 plus columns of data that we want to analyze. This, of course, fortunately is an offline analysis, so not much of a challenge. We wanted to find out what is the baseline consumption, energy consumption of this plant, as well as we wanted to decide the target for future. This is the kind of energy consumption that this plant should be targeting over, let's say, next 1 year or so, and compare the plant performance in energy consumption with its peer plants, similar plants, and then of course develop the energy dashboards, etc. I will again skip some of these. The second one is an example from a batch processing plant where again there is a huge amount of data that has come. The plant has got almost like 24 different batch reactors and we have 386 rows and 12 columns of data which is to be analyzed to find out which is the most efficient reactor out of these, or which is the most or the least efficient reactor out of this, and then build a actionable strategy to improve the efficiency of a particular reactor. Again, these are some of the plots that we developed during this process to finally arrive at which is the least performing reactor and what could be the reason why it is the least performing reactor. The last example is from a storage and shipment terminal, which has got almost 700 equipments, almost 1,000 sensors were put on this plant. Our job was to identify the right sensors for all these equipments, buy them, install them, and then get the data from all these sensors to a centralized control room, and then enable remote monitoring and predictive analytics for this plant. These are the kind of equipments that we covered in this. You can see these are not only chemical engineering equipments, I mean pumps, compressors, rotary equipments, but also storage tanks, heat exchangers, strainers, lot of relief valves, and so on, right? Interestingly, in this project, sorry, once we got all the data was actually communicated from the site in Bangalore to our office in Pune. So the data analytics is being done in real time, not at the site, at back end, at our office, and we are issuing the alerts and the predictive monitoring information back to the plant. And many alerts that we issued were actually reconfirmed by the plant that yes, what you have noticed or what you have observed is actually right. So the technology works, as simple as that. Okay, I think that is the last part. I would like to stop here with the conclusion slide. I think I still have time. Chemical industry is becoming appreciative of data. People have started using, big data analytics. Investment in low-cost sensors is increasing. I've seen more and more chemical plants, buying and putting sensors. I noticed that when I started my career in the refinery, instrumentation used to be really cost prohibitive. We used to have, like, on an average, just about 10,000 sensors in a plant of about 3 million ton capacity refinery where I started my career. Today, a typical refinery will have about 50,000 sensors. So imagine the kind of data that being generated. Data integrity, data availability is becoming important. A lot of time people used to have fear that if this data is exposed, suddenly some very confidential performance related issues will be leaked out to press or will be leaked out to our competitors, right? So people used to be very protective of data. Fortunately, that is changing. Data linked to process models or data linked to statistical models or AI models for doing real-time performance analytics, I think, is definitely becoming popular, and I hope it will be adopted by the industry in right earnest. So thank you very much for this opportunity and for this patient hearing. Okay.
You have to carry. We can keep it there, they will pack it. And this is this is a personal gift from my side. There's a book, The History of this Institute. Please read it, and written by me.
Great, thank you. Surely.
You
I can give this?
Yeah.
Thanks a lot.
We will have now Dr. D. Bhattacharya, Technical Director of Vision Craft Industries. He is giving a Chemcon invited speaker speech. Yeah. Dr. Bhattacharya has done his master's from IIT Kanpur in 1980 and specialization in polymer science and engineering. Then he had his doctorate degree from McMaster University, Canada. Principal research area of research was polymer reaction engineering, supervised by Dr. A.E. Hemiel, Technology Counselor for Johnson & Johnson Baby Products, Division of Skillman, New Jersey, USA. He is experts in modeling and optimization of radiation-induced polymerization of super absorbent polyacrylics, transferred know-how from General Electric, New York, USA, and implemented technology related to high-performance insulating materials in Sahibabad, Uttar Pradesh. Engaged in all aspects of manufacture and R&D of Rotomac Electrical, Delhi and Kolkata in the areas of insulation of high HP traction motors as Director Technology at the moment. Dr. Bhattacharya, you follow.
Good morning to all of you. It gives me unbounded pleasure to be part of this select gathering drawn from such eminent researchers working on the forefront of technology, researchers drawn from India and overseas. At the very outset, I would like to confess that I bid adieu to the hallowed portals of academia way back in 1986. Since that time, I have been engaged in polymer applications to a variety of problems. The topic of the day and the topic that we want to discuss today has engaged my attention over the last 2 decades. And I think it is a burning problem which confronts us not only in India but worldwide. I feel, as I said, I feel honored to be addressing a gathering where we have talked so much about environment. I want to steer your attention, collective attention, to an aspect that hurts the environment perhaps more than anything else today. Before I actually go on to talk about it, I would like to just tell you about the contents of this discussion. It's fairly obvious, so I need not stress on the individual points too much. But corrosion is what we are going to be focusing on today. Corrosion, as it affects everybody, it is ubiquitous, it is found everywhere surrounding us, and the humongous cost that everybody pays is something that should really rivet our attention to. I mean, we should focus on this. I have just briefly outlined the magnitude of corrosion and how it affects the environment. You see, we talk of hydrogen, we talk of many things today, but unfortunately, there are certain items which cannot be replaced because of their versatility and the cost. Cost is an integral aspect of everyday business. Steel, for example, can be modified, it can be worked upon. There are various alloys, various ways you can modify it. But because of its cost and its universality in use, it is difficult to replace it, at least in the near future. Attempts are being made in composites and honeycombs and what have you, drawing upon polymers, importantly. But it still remains perhaps the most versatile material as far as infrastructure is concerned. Similarly, aluminum is perhaps the material of the future. Aluminum, magnesium alloys are stepping in a very, very important way. I mean, they're taking the place of steel in very many applications. Unfortunately, all these metals leave their carbon footprint, and which is so very, see, just have a look at, this is all available from Wikipedia, 1.85 tons of carbon dioxide is emitted per ton of steel. Can you imagine the impact? And parallelly, you have a 200 kg per capita usage on a worldwide basis, that is, per person, annually, that is. So you cannot do without it, and each time you produce it, this is what you're emitting into the environment. This is methane, CO2, all combined. Now, there are fancy technologies coming in, right? DRI is touted to be the route for steel in the future. But do not forget that for high quality steel, you still need the sponge iron to be processed, right? You could have electric arc furnaces, but most of it is still going to be processed in blast furnaces. So you will require what are fossils, I mean, the coal-based fossils, at least for the near future. Hopefully there will be solutions in time to come. But each time you throw away steel, because it's eminently recyclable. Steel and aluminum are eminently recyclable. But what we forget is each time you recycle them, you again require energy-sensitive, energy-intensive processes. So the emissions continue. What is the solution then? Given the fact that there are two basic tenets of chemistry. One is most metals tend to oxidize. It is inevitable that they will oxidize, right? And the other very important tenet is the fact that I think many researchers have not focused on to date, is the fact that anhydrous oxides are nature's first defense to metal protection. So if one could utilize this concept and develop technology around it, then he or she can possibly render a very effective solution to preserve metal for the longest possible time. Obviously, the last point talks about increasing the lifespan of the material of use. The less you recycle, the better it is. So, if we were to discard this throwaway culture and try to increase the longevity of existing structures, and I must quickly point out that by structures, we mostly talk about hot rolled steel, HRS in short. Again, because of its multiple utility and low costs. So, if we were to increase the lifespan of steel, galvanized steel, aluminized steel, what have you, for the longest possible time, if we could use it, then you are contributing directly to lowering emissions in the environment, into the environment. Now, that has been our singular focus, the guiding philosophy, if you will, to look at metal preservation in a manner that I'm very proud to say has not been done to date. Though corrosion engages the attention of researchers worldwide, there's a frenetic amount of activity going on. But very little has been done to look at oxidized metal, because that is the natural state of metal. How can you somehow preserve metal in its pristine form without going for things which are exceedingly deleterious to the environment, things like blasting, things like chemical pretreatment? What happens to these things then? They get into the aquifers, they get into the environment. What does not go up into the air goes down into the ground. All of you are aware of the hexavalent chromium business. But there are many other things which foul up the water. And because everything eventually seeps into the water, you must realize each time metal is scrapped, it contains a whole lot of paints and what have you on top. That also goes to the ground and it leaches into the ground. So, the objective, therefore, is something that takes into account the nature of the metal and then builds a protective layer around it. The interesting thing in this is that you can take black hot rolled steel, which everybody knows contains mill scale. The jargon is a bit, I'm drawing upon bits of metallurgy here, and I hope I'll try and elucidate that by examples to the extent I can, because there's a whole lot of material science which goes into this. Mill scale is a combination of ferrous and ferric oxides, and most of it is actually, it is a ferrimagnetic material, and it is recognized as one of the most stable forms of iron oxide. Now, unfortunately, being porous in nature, water vapor gets into these pores, contacts the active metal underneath, and creates hydrated corrosion products which are voluminous in nature, and these fling the mill scale from the top. Okay, so active metal is continually exposed, and you see what we call a rust loosely for steel. Other metals also corrode in a similar fashion. Aluminum, for example, is a classic case. You would know that aluminum is protected by anodization, which is nothing but controlled oxidation. So as I said, nature has already given us an insight, or has given us a hint at least, as how to go about protection. It just requires a bit of ingenuity to use that and look at the whole plethora of metals. Everything, zinc for example, wants to oxidize almost immediately, right? Anyway, the objective therefore is to extend longevity of existing structures and commence from the protection of hot rolled steel in the manner that it is made, and that is with mill scale. So this technology affords you an opportunity to do that without resorting to such processes like blasting or chemical pretreatments and stuff like that, getting rid of the innate protective layer, which is the oxide, the metal oxide. I won't dwell on this too much because these are, anyway, these are the most important things which can value add. The principles have been outlined, except for the fact, please focus on the last point here. You see, you want to create an interface which is the seat of corrosion underneath the paint. And in order to do that, what people try to do is to create barriers around the metal, forgetting that there is a limit to what you can do. The physical properties of this barrier eventually starts to suffer. And through these pinholes and cracks and stuff like that, water vapor and air seep in to the interface, and and that is the the corrosion goes on unchecked. So we have focused on the interface as the since it is the seat of corrosion, it is also the point where metal loss occurs. So if you want to quell metal loss, the only way to do it is to seek anodic passivation, if you will. This is the basis of formulation. Again, what follows from metal loss is pitting, and even stainless steel pits, the stainless steel is given to pitting very easily in strong chloride and chloridic atmospheres. So every interface has to be looked upon with great interest to try and see how you can quell this activity. The other important thing is the fact that if you were to use galvanized steel in especially in the developing world, for example India, where rampant industrial pollutants are being emitted, and this will increase, this can only increase with time. With the acidity in the environment, especially the sulfurous emissions, zinc becomes a very inadequate choice. You would note here that zinc-rich coatings have often underperformed in India, though they do exceedingly well in cleaner parts of the world. The fact is that inherently it is more reactive, and therefore this depletion of the zinc, if it is deposited on metal, takes place at a very, very fast rate. So, if you want to protect galvanized structures, again, use this same principle of protecting an oxidized metal. Can you do that? And that was the challenge, right? How does one do it? The concept revolves around, self-priming coatings are nothing new. I think, if memory serves me right, early part of 1930s is where this whole concept started. That the best way to protect metal would be self-priming, right? Forget primers which are loaded with corrosion inhibitors or simple barrier coatings, layered coatings, heavy deposited coatings. No. Let's look at self-priming coatings. The idea was, of course, developed in the United States, and a lot of work was done. That idea was implemented on sheet metal with great success. But hot rolled steel is a different beast altogether because of the fact that the way it is produced and cools off in air from a very high temperature to handleable temperatures, right? It produces layered blast off the mill scale. The moment you do that, you activate the metal and it starts to corrode even faster. So you want to prime the metal, you want to then put multiple coats on it, and then use it for infrastructure, various kinds of infrastructure. No matter what you do, you cannot prevent oxidation. And this is where the whole problem lies. If the metal starts to oxidize, subsequent to blasting it, then most protective coatings will not work, I mean, they will work, but they won't give you the expected life because they don't have the innate capacity to work with oxides. They require high surface energies on the top, which is provided by the blasting techniques. So this is one problem. So we looked at it, I have looked at it in a different manner altogether. A specialty polymer, vinyl in nature. Now, I must confess here that some of the work that I am talking about is in the published domain. I have published it. But most of it is proprietary and it's actually patented. So I am not at liberty to talk too much about compositions, but I'm giving you the general philosophy of what this is all about. A specialty vinyl polymer which forms an IPN-like structure. Now, for the uninformed, an IPN is an interpenetrating network. It's a special class of polymeric domains which allows very limited, if at all any, cross-linking. What that does is you can have a very tight packed dry film, very tight packing of linear, in this case these are linear molecules, right? Linear polymeric molecules give you a strange combination of properties, flex as well as hardness. If you were to cross-link materials, which are resinous systems like epoxies, PUs, siloxanes and stuff, you gain a lot in terms of lowering of free volume, right, through cross-linking. But the problem is there are some holes created in the structure, whole kind of free volumes, HOLE that is. And progressively the material becomes so hard that the flex is gone. And if you do not have the requisite flexibility when you are protecting structural steel, or for that matter any metal which has high expansion coefficients, then you have a problem. So a linear matrix of long macromolecular species preformed which can transform, and this is very, very important, which can transform a whole array of oxides. Now, if we were to talk about iron, then you are aware that iron, oxidizes in a number of forms. the oxy hydrous forms, FeOOH, lepidocrosite, acagonite, various forms of oxides are there, which are hydrated in nature, and the dry oxides, right? Like hematite or magnetite or magnemite and so forth. So there is a whole array of oxides. Now, if the coating has this capacity to quickly transform these oxides into one passive form of oxide, which does not change its form subsequently, then you have, I think, largely solved the problem. So that is the first effort. Then you must find a way and means to hold on to this oxidized phase. And this should be beyond physical adsorption. It should almost become part of the metal. So some sort of a chemisorption should take place on the oxidized metal so that the polymeric film becomes almost a part of the metal and its oxidized layer. Now, similar illustrations are available though in smaller molecules, and I have written about water-soluble phosphorus-based organic compounds. These are extensively used in protection of oil wells because of their activity to hold on to metals and their oxides. They are used extensively in metal fines separation. They have tremendous applications in biomedical engineering today. Okay, and but these are small molecules, water soluble in nature. The uniqueness of our scheme is the fact that limited hydrophilicity, which is there, of these groups, which are phosphate groups, which are attached to a hydrophobic vinyl polymer chain. That gives you almost a controlled release action and therefore a very long-lasting effect in corrosion prevention on metals. So, I have already talked about all this. You can completely avoid deleterious practices like blasting, for sheet metal chemical pretreatments, the use of often very polluting corrosion inhibitors. We have a scheme which comprises a base coat and a top coat. The top coat has been expressly made to withstand a whole range of chemical environments, acidic or alkaline, and impart the necessary UV protection and the barrier protection, because a barrier is necessary. You want to control or regulate the ingress of the electrolyte into the interface, but you cannot prevent that from happening for long periods of time. Eventually, the water, vapor and air will finally migrate to the interface. What happens thereafter? That is the question which barrier coatings have not been able to address at all. This is a brief illustration. As time is drawing near, I'll just quickly point out to the fact that some of this work was conducted at NML in Jamshedpur, and I'm greatly indebted to them. A Raman spectra carried out on pre-rusted steel is the first picture there. It gives you the very many peaks of iron oxides, including hydrated iron oxides. It was protected by a scheme which I have outlined earlier, and then exposed to 1,000 hours of salt fog study. Then the coating was stripped off, and the Raman spectra of the interface now, which is bare now, reveals only one single peak. You see, all those peaks earlier have collapsed into one single peak. This single peak is of magamite, known as one of the stablest forms of iron oxide that man has seen. It will not tip into corrosion products any further. This is the EIS work carried out. EIS refers to electrochemical impedance spectroscopy. This was also conducted at NML. The higher the pore resistance, naturally the better is the protection. You can see when a coated panel was exposed to a saline environment, the pore resistance over a period of 4,400 hours or so remained at giga levels. Anything which falls below 10 to the 6 ohm centimeter square is deemed a failure. The interesting thing is, it has actually climbed 2 decades after exposure. Now, this kind of work has never been done anywhere in the world. Oxidized metal has never been studied anywhere, whether it is in EIS or even any other kind of study. This is sorry, I'm running out of time. I would have loved to dwell on these aspects, but then I have covered the guiding philosophy and what you can achieve. This is just a compilation of properties that could be achieved. Work that was done here and overseas in some of the leading labs overseas. And all of this bears testimony to the fact that complete protection can be had on pre-oxidized metal. This is the salient aspects of the polymer and the IPN kind of network that I was referring to. This is the impact. This is an important slide, so I'll just take half a minute and dwell on this. The impact on this, on the environment is significant. It eliminates extensive surface preparation. It provides lower coating thickness to protect metal. The emerging applications are embedded concrete rebars and marine structures. The Indian rails, for example, these could be a very, very important area that we want to target. And I just wanted to mention that this has been already applied at some of the most corrosive locations in this country, both inland and maritime, with great success. I just want to conclude by saying that this is a revolutionary approach in metal protection, which utilizes the inherent passivity of metals through its oxidized products and eliminates many of the toxic practices which hurt the environment. That is it. Thank you, ladies and gentlemen, for your kind attention.
Thank you, Dr. Bhattacharya. Now, we shall have the privilege to listen to Professor Yogesh M. Joshi. Professor Joshi has done his BE from University of Pune and PhD from IIT Mumbai. After his PhD, he has done PDF at Benjamin Levitz Institute of Physicochemical Hydrodynamics, New York. Thereafter, he joined IIT Kanpur and currently he is a professor in the Department of Chemical Engineering. His research area is structure and dynamics of colloidal glasses and gels, soft matter, rheology of complex fluids, and polymer nanocomposites. He has more than 100 research papers in reputed international journals. He is editor to so many journals, including Langmuir. He has many awards to his name, including Shanti Saru Bhatnagar Award. He has been elected fellow of many societies, including the Society of Rheology. He is currently Pandit Girish Sushma Rani and Sushma Rani Pathak Chair Professor of IIT Kanpur.
Okay.
He is also the Vice Chairman of Local Organizing Committee of Chemcon, this Chemcon. I welcome Professor Joshi to give an invited talk on the topic, Using Rheology to Determine the Phase Behavior, a case study of colloidal suspension of charged discotic particles. Professor Joshi, your floor, please.
Thank you so much, Mr. Chairman. I'm just opening my presentation. Great. Okay, so this title looks a bit fancy, right? But it's very directly related to chemical engineering, and I'm going to show you how and importance of this particular study. Yeah. So, is this okay? Yeah. So, charged discotic particles. All right, the way we can give many fancy names, like a simple human being can be called as mammals. So charged discotic particles are nothing but simply clades. All right, and of course the present talk is going to be, my talk is going to have a different flavor than my predecessor. He talked about metallurgy, but even in mining industry we know that we have to deal with a lot of clay debris. And dispersions of clades are very, very commonly used in chemical industry. All right. So it's a very interesting study, a very academic study, but with huge application potential. I myself work with various industries, chemical industries, and I'll essentially try to portray the industrial importance of this particular system as well. So, before beginning my talk, let me just kind of take you through some of the fundamentals, and that fundamentals are essentially as follows, that we know that there are three states of matter, solid state, liquid state, and the gaseous state. as far as the condensed matter is concerned, we talk about elastic, so the solid state as well as liquid state. All right. And these states we encounter obviously continuously in any of our walk of life, either domestic, industrial, or whatever. Now, there are two extremes as far as these materials are concerned. One extreme is ideal solid, which is elastic solid, and ideal liquid, which is perfectly viscous liquid. All right. And those who have done any class in solid mechanics or fluid mechanics or even physics know that in case of elastic solids, we essentially have stress proportional to strain, while in case of liquids, we have stress proportional to strain rate. All right. And strain rate essentially means that if there are two surfaces with one surface fixed, other surface moving with certain velocity v, and if these two plates are separated by distance h, then this gamma dot is nothing but v by h. All right. So, it is as simple as that. Now, we very often encounter solid liquid transition in our industrial life. We need to do melting, we need to do solidification. All right. So, such kind of transformations are continuously happening when we deal with materials in industry. Now, how to distinguish different kinds of solid to liquid transition? Anybody will say that, well, it's a very silly question. You essentially have melting when solid becomes liquid, and you have again solidification, crystallization when a liquid becomes solid. But crystallization or solid liquid transition through melting is the only thermodynamic way of having this particular transition. The other ways are, of course, material can undergo sol-gel transition. Material can undergo glass transition. All right. And when such transitions occur, the response is very different, and such response can be very uniquely obtained using rheology. Now, this is a bit crowded slide, but I'll try to explain this. So, what is done is very simple. You take material between two plates and you simply apply oscillatory strain field. You oscillate top plate. All right. When you oscillate top plate, we simply means that you are giving a sinusoidal displacement. When you give sinusoidal displacement, what comes out is sinusoidal stress. And what you are going to measure is that for a given sinusoidal displacement, how much is the magnitude of that sinusoidal stress and how much is the phase lag between the applied strain and the stress that you measure. All right. So, these are the only two properties that are measured. So, this is the strain which is applied, which is sinusoidal strain. You can see here it's a perfectly sine wave. Okay. Derivative of strain is strain rate, which is nothing but this. And you can see that the strain and strain rate are perfectly out of phase with each other, which means that the crest of one is trough of the other. Okay. Valley of one is the peak of the other. All right. Now, if a material is perfectly solid, then stress response will be again perfectly sinusoidal in phase with strain. If material is perfectly liquid, then stress response is in phase with strain rate. For a material which is in between, which is not like exactly solid, not like exactly liquid, a typical such materials are our ketchup, mayonnaise, jam, egg yolk, the shampoo that we use. All right. So, for such materials, the stress response is in between the strain input and the strain rate input. So, strain and strain rate are perfectly pi by 2, which is 90 degrees apart, and the stress is in between them. All right. So, what you can do is that for elastic solid, stress is in phase with strain. For viscous liquids, stress is perfectly in phase with strain rate. For materials which are in between, it's some kind of a phase lag delta, and this delta can be resolved in part of the stress wave which is in phase with strain, which is solid like, and part which is in phase with strain rate, which is liquid like, which leads to G prime, which is like a solid like behavior of a material, and G double prime, which is like a viscous behavior of a material. All right. So, I will be using this G prime and G double prime often as far as this talk is concerned. many talks you may have wondered what G prime and G double prime is. It's very often obtained. Yeah, please take a photo if you want to. Otherwise, mind that in professional conferences, taking photo is banned these days. But you can take photo. You can take whatever photo you want of my talk. Okay. So, how does this G prime and G double prime behave? So, if you take a ball and if you just drop a ball, then the height to which it recovers is typically proportional to G prime, while the height to which it cannot recover is typically G double prime. All right. So, if it's a ping pong ball, then it has high G prime, low G double prime. If it is a tennis ball or even the cricket ball, then of course it will have lower G prime and higher G double prime, so on and so forth. All right. So, this is typically how you can relate. Okay. Now, another concept, what is relaxation time? Now, relaxation time is that time over which material stores its energy. All right. Every material has an inherent instinct to dissipate energy. Nobody wants to keep everything stored. All right. They want to dissipate. All right. Only the perfect crystalline materials store energy for infinite time scale. All other materials dissipate. But the time over which they dissipate is called relaxation time. Liquid water dissipates over the time scale of 10 to the power minus 14 seconds. That's why it's liquid. Diamond retains it over millions and millions of years. That's why it's perfect solid. All right. This is how relaxation time is defined. And the three different kinds of liquid solid transition that we come across are liquid crystal transition, which of course can be perfectly obtained using calorimetric studies. You do DSC and you get liquid solid transition, which is a crystalline transition. There is another transition which is called glass transition, which is also very often encountered in industry. And of course, sol gel transition. The very previous speaker talked about network formation, cross-linking. That is nothing but sol gel transition. All right. Now, how to distinguish? Now, all these transitions can be very nicely distinguished using rheology. All right. And I am not going to dwell much time on this. But before that, of course, this is an important slide. Glass is typically like this. Gel is typically like this. Okay. Typical encounter, what we encounter is, in polymers we encounter gel. In polymers we encounter glass as well. All right. Now, rheologically, how to distinguish between these two states is a very, very important question. All right. So, much credit goes to a person called Henning Winter. He is from University of Massachusetts at Amherst. And what he essentially said is that applied frequency means if you are doing these rheological experiments, then you essentially oscillate the top plate with respect to certain frequency. And if you vary this particular frequency, then for gels, you get a state where both G prime and G double prime show a power law dependence on frequency and are parallel to each other. That's a classic state where you have gel. All right. On the other hand, for glass transition, you always see a peak when you plot G double prime by G prime, which is nothing but equal to tan delta, as a function of the variable which you are essentially varying. So, you know that with change in temperature, glass melts. All right. It shows peak, but as a function of frequency, the position of this particular peak changes. That is glass transition. All right. But the same tan delta, if you plot as a function of frequency, then in case of gel point, it shows complete independence on frequency. So, these are the kind of subtle points. All right. Why I am taking so much of background? Because we encounter this beautiful clay dispersion. So, you take this particular clay. So, now there are many clays in market. And typically, those which are used in industry very dominantly, those who closely work with petroleum industry, mining industry, petrochemical industry, paint industry, so on and so forth. Typical additives that are used are called bentonite, colosite, montmorillonite, and there are several such ites, okay, which are used in industry very, very predominantly. All right. We are going to focus on one such baby in this particular family, which is called laponite. All right. Now, this laponite is a typical disc-shaped clay particle, For all practical purposes, it's a nanoparticle. It has diameter of 25 nanometer. Its thickness is 1 nanometer. Its face is negatively charged. Its edge is positively charged when dispersed in water. So when in water, these laponite particles have repulsion, which is face-to-face repulsion, but it has attraction, which is edge-to-face attraction, which can be represented either in we come across. So you take a water, and you take only 1 volume % of clay. Keep in mind there are 99 parts of water in this, and you are adding 1 volume % of clay in this. We have just added some salt because the process gets accelerated. We added 1 volume % of salt. In weight percent, it will be close to 3%. The solution becomes hazy. After a while, solution becomes so clear that if it's put in beaker, then you will not be able to figure out difference between water and this particular laponite dispersion. And after few hours, just this 1 volume %, when there is 99% of water in it, becomes so stiff that it supports its weight. All right? Which means that these 1 volume % of tiny laponite particles must be forming some kind of structure in water that leads to such high stiffness. As a matter of fact, the elastic modulus of these particular materials is of the order of 100 pascals. All right, which is very significant. When viscosity of water is 10 to the power minus 3 pascals second, here we are talking about elastic modulus to be 100 pascals, huge increase in elastic modulus. You will feel as if you have taken thick Nivea cream in your hand when you touch this. All right. So what kind of these tiny particles they forms, what kind of structure in order to get such extraordinary stiffness? So that's question which has bothered physicists, chemical engineers, chemists for over 3 decades now. All right. And the 2 pictures were proposed. In one picture, it was proposed that all these particles form a space spanning network, like a network with edge and face attraction. While one group, which was very predominant, that suggested that all these particles remain self-suspended in water in a repulsive environment. You must have seen magnets, right? If you get 2 magnetic kind of same poles next to each other, then you can feel there is repulsion, isn't it? So similarly, it was proposed that these negative charge repel each other, and because of that, all these particles are now self-suspended in water, which gives it such a huge strength. Now, of course, this bothered us a lot. We have been working on this particular field for a long time. And so what I'm going to do is that I'm going to take you through briefly how much massive work has been done on this particular system. But before that, this laponite is produced by this particular company called BIC company. And you look at the industrial uses of this particular laponite. So we are not talking about some stray academic exercise over here. Millions and millions of dollars are essentially spent to use this specific clay, and further many millions are used to use another clays in the same family. So the work that I'm talking about is, though while academic, has huge industrial relevance. All right. So first phase diagram published in 1995, which is something like more than 2 decades back. All right, where this is concentration of salt, this is concentration of laponite. It's a simple diagram. They say that below certain concentration it's sol, above certain concentration is gel. All right, and at high salt concentration, everything phase separates. Very nice. 1995. Keep this author names in mind, Morchid. After a few years, they did work and they thought that, well, this is not the best one. They came up with another one. Okay, I'm not going to go into details of what all they proposed. Then a third group came. This group, of course, the name is Japanese, but the group is Dutch. They came with, this became very popular, very busy phase diagram, where they say that, well, there is attractive glass over here, Wigner glass means repulsive glass over here, phase separation over here, so on and so forth. All right. But then same group came with another particular plot, which of course I'll show you later. But now, meanwhile, another group resurfaced from Rome. They proposed their own phase diagram. This is the phase diagram proposed by one group which has proposed this phase diagram. So they kept on correcting their phase diagrams, and many, many phase diagrams came about until there came a paper in Nature Materials, not any ordinary journal, Nature Materials, which has impact factor of the order of 40, and they did small angle X-ray scattering, and what they proposed is that for low concentration laponite, there must be an edge to face like of combination, and for high concentration, the particles cannot touch each other. That is what the claim they came about. All right, and based on that, they came up with this particular phase diagram. All right, wherein here they say that it's a repulsive glass, which means that at high concentration, particles cannot touch each other, but at low concentrations, particles must touch each other to form a glass. So this is what they claimed. All right. Our group is also working on this particular system for past now close to 18 years. The year I joined IIT Kanpur, we have been working on this particular system. And we always observed that signatures are close to this picture, and we never observed this particular picture. And that always used to make us wonder on one hand and make our life difficult on the other hand to publish our papers. All right. After doing lots and lots of study, we realized that this problem is, so we always thought that this all structure is like a attractive gel. All right. We realize the problem is typically this old tale where we are all blind and we are trying to figure out various things. But since we do not have a big picture, we have our own convictions, and our convictions are so strong as our egos that if I am saying something, then it cannot be wrong. All right, but since we do not have that big picture, we essentially tend to get carried away by our own conviction, and this is what precisely was happening in this particular field. All right. So what we did is that we took a system which is 2.88% laponite dispersion, which actually is slightly over 1 volume percent, and we subjected this particular material, we took this material between two plates and we subjected it to, literally speaking, oscillatory shear rheology, a very simple experiment if you have a rheometer, and we simply changed the frequency. So the vertical axis of this is frequency, and we did that as a function of time. All right, so we increased frequency, then again going back, so we kept on doing this cyclic frequency sweep, and as a function of time we simply obtained G prime and G double prime as a function of time, and this is the concentration that we talked about, which is deep in the repulsive glass state as proposed by that Nature Materials group. And what we observed is that in this case, the G prime and G double prime indeed shows a parallel type of response with respect to frequency, showing a very clear picture of gel and not glass, which led us to believe that, well, there is something wrong with this particular picture, which is not right. So what we did is that we decided to explore all the concentrations. So we studied all these concentrations. And for all these concentrations, we again got picture of gel, which means what has been a cryo-TEM machine through a 100 crore grant which DST had given him. And when that machine was getting installed, we were the first ones with our samples standing in line. All right. And we again went to our decided concentration. We want to study, we want to take pictures at this particular point. Now let me say this, that this was a turning point moment, because if we would have gotten a picture where all the particles are self-suspended and they do not touch each other, then which means that the Nature Materials picture would prove right. If the particles are touching each other and if they formed a network, then our rheology picture has come out to be right. All right. So this is what the picture looks like. All right. So you can very clearly see that there is clearly a network. the particles are certainly not self-suspended in repulsive environment of each other, but while they are touching each other, and they formed a percolated network, which actually kind of led us, our theory, rheology as a tool, it led to its vindication that yes, it indeed is an attractive gel, and thus now with this we claimed that we have put to rest a study of 30 years. So this is at a magnification of 1 micrometer. You can see that this is 1 micrometer length scale. Not this one, but this one. You can see that you can see a very clear network being formed of these particular laponite particles. And by doing that, we put to rest a 3-decade-old controversy, which essentially led to publication in these 2 journals, where we actually now said that, well, it's indeed an attractive gel. All right. So with this, let me summarize my talk. The freshly prepared laponite dispersion shows identical behavior, which is shown by polymeric materials that undergo sol gel transition. So therefore, that led us to believe that rheologically it indeed is a sol gel transition, which means that it must lead to an attractive glass formation. The critical gel of laponite shows all the rheological characteristic features showed by critical gels in other kind of soft materials. And more importantly, cryo-TEM confirms this particular behavior. Interestingly, this material is proposed to be repulsive glass using scattering studies and some other kind of techniques in the literature. We then took on all those techniques, and in our review paper we showed that how all those techniques have led to erroneous results, and how the experiments are needed to be performed in a right way in order to get the right results. But that's going into much details. The point over here is that using simple mechanical analysis, rheology is a purely mechanical analysis, you can get deep insights into material behavior. And these materials are extremely industrially important materials. All right. So with this, let me conclude my talk, and I'll be happy to take questions if there are any. Thank you.
Any questions? Yeah.
Yes.
Please stand up and tell your name and where you are studying, and then. Yes, please.
In the strain and strain rate, like if we calculate for any material strain rate like d by dt, so the difference phase difference will be pi by 2 always. But sir, you told like it depends upon material and can also be in same phase.
The difference between strain and strain rate is always pi by 2. Strain and stress depends on material. Are you getting it?
Yes, yes.
So stress is proportional to strain in case of elastic solids.
Yes.
Stress is proportional to strain rate in case of viscous liquids. Okay. Strain and strain rate is just the 90-degree separated parts of the same wheel. All right. So the phase difference between strain and strain rate will always be pi by 2.
Okay.
But if you are using elastic solid, then stress response will be precisely in phase with strain. If you are using viscous liquid, then the stress response will precisely be in phase with strain rate, or it will be out of phase with respect to strain. But if you have material in between, which is not perfectly viscous solid or which is not perfectly viscous liquid, like many materials that we come across in our day-to-day life, like toothpaste, shampoo, various kinds of food materials, industrial slurries, paints. As a matter of fact, every other material that you see in a chemical industry is a viscoelastic material. For these materials, stress is neither in phase with strain nor in phase with strain rate. It's somewhere in between.
Okay.
And that phase angle determines what the property of the material is. More elaborately, how that phase angle depends on the frequency of oscillations determine what is the behavior of that particular material.
Sir, my next question is like you told like water releases energy in very less time, like 10 to the power minus 14. So like we can see if we
Can you please ask your question slowly? So what was your first statement?
so like water releases its energy in very less time.
Yeah.
So and like solid retain its energy. So like if water will release this energy, so we can like see increasing kinetic energies by in release, and solid will retain its energy. So like in case of diamond, how we will see the energy?
Okay, so you understand that why water will release its energy and what will happen to that released energy?
Yeah.
So it's something like this. If you, it's old Joule's experiment, right? If you take a beaker of water and if you add a stirrer to it, and if you increase, if you put a thermometer in it, then if it's a calorimetrically insulated, then simply stirring that particular liquid will lead to temperature rise, which means that the energy that is getting released essentially is increasing temperature in that case. Now in case of diamond, first of all, or forget about diamond, let's say even steel. Okay, steel is also pretty much elastic for typical time scales that we use. So if you, let's say if you take a steel rod like this, okay, and if you apply tension to it, all right. So when you apply force to it or stress to it, it will get elongated because of course depending upon the Young's modulus of that particular steel. If you remove that particular stress, then it will come back. So stored energy will be released in elastically restoring the material back to its original state. But if you have water and if you apply strain to it and if you release it, it will not come back because that has dissipated as heat. All right?
So like I was thinking diamond like so much energy like in the form of pressure is being given to the diamond. So like if like how we will see that energy?
That is when diamond is formed. We are not talking about the diamond formation process. We are simply talking about what is the stress
So the stored
response to strain in a material. All right?
Okay.
When diamond is formed, a complete chemical transformation occurs of the carbon to diamond. It's a completely different process and that occurs over thousands and thousands of years, if not millions.
Okay.
All right?
Yes.
So that's a totally different ball game altogether.
Okay. Thank you.
Any more questions?
Hello, sir. I have seen all your slides and try to understand.
Kindly introduce yourself.
Yeah, myself Sheikh Amir Ali. I am a research scholar from IIT Kharagpur, and I have seen all your slides and try to understand that you have explained all the work based on the storage modulus, and but my thing is that laponite particle based on which behavior they are trying to attract with each other, either when the quantity is increased, their behavior are same as in the low quantity, means what is the property that means help to assembling the particle in that manner.
Okay. So in a dry state, nothing is positively charged or negatively charged. Everything is neutral. All right. So consider this to be one laponite particle, this to be another laponite particle. Okay. In dry state, both are absolutely neutral particles. But this particular particle is such that there contains sodium atoms on faces of this particular particle. Okay. So when you add this particular particle in water, the sodium ions dissociate, rendering face a permanent negative charge. All right. Now, edge of the laponite particle typically has magnesium oxide. Okay. Now, if pH of water is below 9 or let's say below 10, 11, something like that, then the magnesium oxide undergoes protonation, which means that the edge becomes positive. It's a typical physical chemistry type of exercise. Whereas MgOH, when you add it in pH below 11, then it acquires protein from water rendering giving it positive charge. All right. At pH of 11, the charge of magnesium oxide becomes perfectly neutral, and at higher pH, it becomes negative. Deprotonation occurs. For MgOH, this typical pH between 11 and 12 is known as isoelectric point or point of zero charge. Okay, both have slight different meaning, but pretty much the same. All right, and such point of zero charge exists for all metals and metal oxides. Okay, for silica it's 2. Below 2 it's positively charged, above 2 it's negatively charged. Okay, so silica will invariantly be negatively charged for most of the pH. All right, so because of that, laponite particles edge has positive charge, face has negative charge. Okay, so what do you expect? When you put that in water, they will attract like this. That is precisely what is happening. More the laponite particles, more will be the network.
Thank you, sir.
I think, any other questions? Anybody? No, I think that's it. Thank you, Professor Joshi. Thank you very much for the nice talk. Yeah.
Thank you so much for giving me this opportunity. I have given many those talks also. So.
I think the last speaker, Dr. Vikramaditya Yadav from the University of British Columbia is not here. So with that, I think we have come to the end of this Chemcon Distinguished Speakers and Invited Speaker lecture sessions. So I think we disperse from here. There is no other lecture remaining. Thank you, everybody, for coming here and attending this and encouraging the speakers and listening to them patiently and getting good knowledge about the research areas they're doing. Thank you very much.
There has been, so what I'm going to do with
दो को 50।
यस बॉस, आपने बुलाया?
कल की मीटिंग की प्रेजेंटेशन का क्या हुआ?
Due to some urgent work, many council member the already returned back. So those who are here, I thanks to all the council member for attending this 4 days program and cooperate with the local organizing committee and make this event a grand success. So I'm requesting to do the felicitation with flower bouquet to the President, Professor M.K. Jha, both the Vice President and Treasurer. So, the President-elect Professor Anil Sarwa, due to his urgent work in his IIT Delhi, he could not make it convenient to be present in this program. So, he has entrusted to our Vice President Professor C.K. Karthikeyan to deliver on behalf of his some address to the audience. That's it. Okay.
Is it audible? Oh. Good evening to everyone. Most respected President, Mr. Dinesh Butala sir, past President M.K. Jha sir, Vice President Mr. Rajanandam, Honorary Secretary Avijit Ghosh, Treasurer Sushant Rai, and respected Vishwanath Chatterjee sir, Trivedi sir, S.K. Gupta sir, council members, delegates and participants of this Chemcon 2022, very good evening to one and all present here. At the outset, I thank all the participants who have overwhelmingly arrived and made this Chemcon a grand success. As you all know that this Chemcon is our chemical engineering Maha Utsav, rather. We all chemical engineers feel one and unique celebration is this Chemcon. This is an opportunity to meet each other and greet each other, and just before, it happens every year, just before a new year. We welcome the new year with much eager happiness and expecting the prosperity in the coming years. None of the organization has a uniqueness that we chemical engineers celebrate every new year in the form of Chemical Engineering Congress. And it so happened that we had a joint symposium with Japan, we had joint symposium with Canada, and we have much integration and collaboration with AICHME and European Chemical Engineering Society. In fact, due to an urgent work, the President-elect, Professor Saravaji, has to leave to his hometown. So I take this opportunity to welcome you all for this Chemcon 2023, and as you make this Chemcon 22 2022 a grand success, kindly come to Calcutta, where we have our headquarters. Kindly make a visit of the headquarters and also attend the Chemcon 2023. I wish every participant a happy, prosperous, happy New Year. Thank you very much.
So thank you, sir, for your brief address to the audience. Now I am requesting outgoing President Mr. D.M. Butala to address the audience.
Good afternoon to all. In absence of incoming president, so for today's function, our President-elect, Vice President, Professor Dr. Karthikeyan, Professor Dr. Rajanandan, my predecessor, Professor M.K. Jha, Honorary Secretary Dr. Avijit Ghosh, Honorary Treasurer S.K. Roy, NOC Chairman Sri Chattopadhyay ji, LOC Chairman Sri Dr. Trivedi ji, my friends at the council, delegates, my dear students and friends, ladies and gentlemen, once again good evening to all, and on the onset I wish you all a very happy, bright and prosperous 2023, and I wish 2023 brings good luck to all of us, and it will be a year which is meaningful to all of us. The year 2022 began with the third wave of corona, but the spirit prevailed. The Chemcon 2022, which was supposed to be last year, fitting to the centenary celebrations of HBTU, unluckily COVID pandemic disturbed whole program, whole schedule, but with the support of everyone and with the spirit, yes, Chemcon at 2022 has been a grand success. IICHE has one unique distinction. It is an unique happenstance that the Platinum Jubilee celebrations of IICHE has coincided with the Azadi Ka Mahotsav, the 75th anniversary celebrations of Indian independence. And coincidentally, I am also running 75. Last July I turned 75. So for me, it was a Platinum Jubilee year. It was a unique opportunity to me to head this August Institute, which has given so many things to all of us. And indeed, the year was pretty hectic, quite busy for me. Instead, as I am coming from the industry, I had my own some of the perceptions compared to my other friends from academician, and I am happy that I had a very good cooperation and support from all of the council members. And during my tenure of 1 year, of course, for anyone, 1 year tenure is a bit small tenure, but we have to follow the system. Because unless we don't have any system, we cannot move anything. As we say in industry, industry always runs on a particular system, and we must follow the system. 2022, I am happy to say, two interesting things has been introduced. See, for any activity, we need vitamin M. Money comes from the industry, and if the money is not there, no activity can take place. And so for this, considering this aspect, industry's values, I have tried to imbibe the two new things. If you have a look at Indian Institute of Chemical Engineers website, there are two new dedicated portals have been started from next year, that is from January 2023. These portals will become active. Now, one portal is the industrial polyclinic. The small and medium scale industries, even the big industries have one or other kind of a problem. So people can put their problem on this portal. The experts from this various field can reply. There can be 4 or 5 solutions to the problem, and it will be left to the concerned person or concerned industry who raised the problem, and the whose advice he is considering, or he can go to any consultancy. The another is particularly for the dear students, millennia students. It is a specific portal targeted to you, all the student community. The portal is named as Ask the Expert. So I know students particularly because I have been connected with a couple of universities on the board of syllabus on the Western India side, and the students do face some typical problem when they have to go for their final project report. Many students have the problems of designing of a particular equipment or reactor or cost estimation and some of the safety issues. And sometimes the literature is not sufficient to fulfill their queries. So they can put their queries on this portal, and friends from academicians and other experts can reply to this, and I am sure this it will benefit to the student. Another area which has been already announced by Honorary Secretary during the programs also, IICH is going to start a special training institute which is specifically going to train the fresh students as well as the professionals who are completed 4 to 5 years of the service, and they have certain typical requirements. So this institute will be something like honing or enhancement of the skill, and it will address to those areas. And also one of the levels there we are going to start is from industries concept. All industries employ the operators in our country. Operators are of the SSC level or BSc pass out. Now many industries, big industries have their own training centers, and they train them or they mold them as per their requirement. But SME sector has a real problem. Some of the big cities or the industrial belts, their bodies like local national council bodies, they train the people, but it is still there is a big requirement. So from that aspect, this training institute will also touch upon that aspect, and it will be this thing. And most interesting and useful point is that this institute will be online. So you don't have to go to Kolkata or whatever the centers we consider, but it will be the online program, and it won't be a one-day program. It will be a pretty long program. We are already finalizing so many details. So these are the 3 important things which has happened in the year of 2022, and I am sure it will benefit to all of us. The journey of institute, which started on 18th May 1947, the journey was it has passed through the troubled waters and come to a milestone of the 75th Platinum Jubilee and the Chemcon 2022. I am indeed really very happy, and my special thanks and congratulations to NOC Chairman Dr. Shri Chattopadhyay ji, as well as LOC Chairman Dr. Trivedi and their team who have contributed. Unless Mr. Chattopadhyay ji has taken indeed lot of pain from his busy schedule in spite of being a CEO of one of the most important organization, sparing the time, because I am from industry. I know when you are at a higher level, to spare the time for other activities is really difficult. And my special congratulations to him, and I say 2 little words, thank you, conveys my heartfelt feelings to him. I also convey my heartfelt feelings to entire LOC team, all the volunteers, all the faculty members who have not turned a single stone to make this event successful. Indeed, this was a really successful thing, and this event had seen 2 important things. There are 3 things. Number 1 is a joint symposium and signing of MOU with Canadian Society of Chemical Engineers. Another one is signing of MOU with a Japanese Chemical Society. And third thing, American Institute of Chemical Engineers, who happens to be the joint sponsor, and the MOU with AICHE, which expired in the month of July 2022, is being renewed. So it is really a very good thing, and particularly for American Institute support. I give special credit to Chattopadhyay ji, as I was trying since January 2022, I was in touch with AICHE President Ms. Barbara, but unluckily there was no response, and because of the Chattopadhyay's special attention and special efforts, we could make it reality. So these are the three important things. And friends, I particularly for young students, I consider this way, ISH is a platform for you to build up your career. Please take interest wholeheartedly. Just do not say that after graduation our faculty members are not there, so we may not continue. Please do not look into this. There are good golden days to come ahead, and the situation is changing. Next 20 years are going to be very, very interesting, from artificial intelligence, green hydrogen, and so many things, where we, young generation, are passing baton to you, younger generation. Thank you all, and once again wish you all happy and bright 2023. Thank you all.
So thank you, sir, for your elaborate citation about the Chemcon 2022 and giving the thanks to the organizer for conducting successful event. Now, there is an address for Chemcon 23 by organizing secretary. So I am the organizing secretary for Chemcon 23. So I am requesting the system department, please project my screen. And requesting Chattopadhyay sir also please come on the dais to release the first Chemcon brochure. Saxena ji and other council member, those present here, please join with the Chemcon first announce release. So thank you. Now just I'll share few important aspect of Chemcon 23. This is the first time Chemcon will be organized by Indian Institute of Chemical Engineers. Why I am telling first time? Because still 75 years it was organized by it's one of the regional center like Kanpur, Bombay, Delhi, Mumbai, Kolkata. But it is going to be held at Kolkata, organized by headquarter. And that is the speciality, that you can feel that everyone is organizing this Chemcon. Being a member of IICG, so all the members are in the organizing committee. So that kind of feelings you should have, and this is our invitation to participate. We are associated already with the Rajiv Gandhi Institute of Petroleum Technology, Jadavpur University and Heritage Institute of Technology, where is the venue of the program. There are special session already we have mentioned, that Indo-Canadian Joint Symposium, other joint symposium yet to confirm. There will be industry summit which are going to be held probably first time, or maybe very few organizers have already conducted, maybe Mumbai have done earlier. But the important aspect of this industry summit is that we should bring some industry there and try to show the importance of chemical engineering to the student community. Because students will be our main strength. Many engineering colleges are facing problem for chemical engineering subject enrollment. So the awareness is required. On this aspect, we thought that one industry summit can be given where the industry requirement chemical engineers can be discussed. At least that can be percolated to the across the country's academic institution and the governing bodies like AICT, UGC, that these are the requirement. So chemical engineering should be in the curriculum and it should be given an in due importance as compared to the other branches like IT and all. We had a media partner, so as of now, Indian Chemical News. Already we had a number of publication journal house already tie up. If you go our website, you will find Indian Chemical Engineers, Taylor and Francis, the special issue will publish. ESP or Elsevier will publish special issue. We will publish a book volume with a lecture note, ISBN and DOI number. Another 3 reputed publishers is yet to confirm. So 5 international journals will be publishing our special issues. At least 250 paper will publish. Apart from more than 50 paper in the book chapter. So this is our target, so that good quality paper from the across the world we are targeting. We have already started initiation with the joint symposium of AICT, what we did similar manner with the Canada. The abstract submission date already declared. Before the conference, we would like to release one journal and which will be inaugurated in the program. So I am requesting the participants, please pass the information, submit your abstract at the earliest, so that as soon as you will get acceptance, you please submit the full paper. Those are willing to submit full paper. So this is our short planning, and as you know, the Kolkata having a we can consider one of the cheapest city. So I hope it will not be a problem for you to stay there. There is a tourist place nearby. We will conduct also, we are planning to conduct one tour, post-conference tour to the Sundarban or Gangasagar, that was we are discussing. You can roam around the city. There is a Victoria Memorial, Dakshineswar Belur Math temple, which is very famous to all. The registration fee is already mentioned in the website, which is as per traditionally we are keeping as low as compared to the any other international conference in this stature. You can compare with the any other conference where the registration fees was there. There is no extra registration fees for the publication. Your registration fees include registration kit, stay, the local fooding and as well as the publication, those willing to submit the full paper. And our theme, if you see, it is already defined that energy transition, challenges and opportunity. That is the very much desired theme given by the Petroleum Ministry, Ministry of Petroleum and Natural Gas, as well as the Government of India, as they are projecting that 2035 will be our hydrogen economy. So the transition from fossil fuel to hydrogen economy, there is a great scope to get idea or exchange idea in this Chemcon 23 platform. Heritage Institute of Technology having a very good infrastructure. Already they have conducted one Chemcon in 2007. We have conducted several international events as compared as it is Chemcon. So the infrastructure is there. There is a good communication from city, railway, airports, Howrah, Sialda nearby, around within the 15 kilometers that the institute is situated. We are trying to provide accommodation in the hostel for the student, as well as we had a number of hotels nearby with a budgetary hotels where accommodation will not be a problem. We can ensure that 1,000 people we can give accommodation with a competitive rate. So with this, I just would like to show the Chemcon website that is under construction, but we have already preliminary launch. Whatever the information you can get, you can visit to the iich.org.in/Chemcon 2023. Those who are attending Chemcon frequently, this is might be the one of the rare Chemcon where all preparatory work for 23 has been completed. Many organizers unable to prepare the website during the first announcement, but we are trying to do as much as advance we can proceed. And I am happy to announce that just today at 12:29 I got bronze sponsorship from Government of West Bengal Power Department. This is the first commitment, and also within a January first week or second week we will get the consent letter from Bamal Lorry with the persuasion of Mr. S.K. Roy. He is the General Chief Manager retired from Bamal Lorry. So they are going to help as our expectation. So what we are thinking that we are trying to move little faster because of the giving importance to the participants, authors and the delegates, so that the publication should be first priority from our side. So once again I welcome you all. Visit our website. Contact details already mentioned in the website. If you need any further information, my contact number is given website and I will be happy to correspond. And normally I don't want to see in my inbox unread mail. At any point of time it will be never find you. So whenever I used to my mailbox, it should be read first. Then, so in this way definitely I will be giving your reply to your query. So I can assure you that you will be getting good hospitality as you are getting here and other Chemcons, but try to improve the conduct Chemcon in a great manner. So thank you very much for giving me opportunity for sharing the Chemcon 23 first announcement. So thanks. I request all the delegates to please give a big round of applause for all the council members, because without their constant effort, I would have not been possible to publish the first announcement. So thank you all the council members. So now the most important part of today's function is the handing over the President medal to the President-elect. As our Vice President already told, due to some urgent work he is not there. So I am requesting Butalaji, on behalf of President, you can hand over to the Karthikeyan sir, he is the Vice President-elect, to receive the medal. Yes. So you have received for Butalaji also. So now I am requesting President sir, Vice President, other dignitaries on the dais to join the felicitation to the local organizing committee. First I invite Mr. Vishwanath Chattopadhyay, Chairman NOC, to come on the dais, because his contribution is unparalleled and I can't put any words how he has passed last 2 years to make this event a grand success. So please put hands together and big round of applause for Mr. Chattopadhyay. President already elaborated how he busy, but still he spent lot of times and make this Chemcon a grand success. And it will not be his end, because next year also he is the vice chairman of NOC. So council also happy to co-opt Chattopadhyay sir as a co-opted council member next year. So next I am requesting another pillar of this Chemcon 2022, Dr. Professor Rakesh Trivedi ji, Chairman LOC. Since the day one, he has also put his continuous effort. And always one word I heard from him that हो जाएगा. चिंता मत करें अभिजीत जी, हो जाएगा. But yes sir, it is हो गया. So thank you sir. Next I am requesting the main architecture of this program, Dr. S.V.R. Sastry. He joined this institute 6 months back, but he has taken this great responsibility without any hesitation, and he has given his all effort with the help of his all young department. Yes, just.
I request you now, the President from IICHU to the Joint Convener of NOC, in this case, Dr. Abhijit Ghosh. Yeah. Yeah, IICHU to the President. Yeah, sorry. Yeah. Next, the award to the Joint Convener of National Organizing Committee, Dr. Abhijit Ghosh. And after that, followed by from Local Organizing Committee to the President and Local Organizing Committee to the Honorary Secretary.
Yes, sir. So now we'll have mementos for the ISHE members, starting with the President of ISHE, Honorable Shri D.M. Butalaji. Please, beta. Next, Dr. Avijit Ghosh, sir. Yes, sir, list.
अरे पूरा काउंसिलर और बाकी जीते चाहिए दिए थे हाँ बोल बोल दे दो हाँ वही हाँ दे दो
हाँ.
So, actually, from local organizing committee, they would like to felicitate all the council member. The list they don't have, I know all the names. So, on behalf of Shastri, I am calling the names. So, yes.
So yes, sir. So Professor S.K. Gupta ji, council member from Kanpur Regional Center. Next बच्चा ready है, next बच्चा इसको बुलाओ, next बच्चे को. Professor M.K. Jha, sir. Professor M.K. Jha, sir, immediate past president of ISHE.
ये देख के बोल दी
Professor R. Pathipan, sir. Next, Professor Anil Kumar Saroha, sir. Mr. Sushant Kumar Roy, sir. Next, Professor Alpana Mahapatra, madam. Alpana Mahapatra, madam. ये पुराना है. हाँ, बाद में करिए. Dr. M.P. Jain, sir. Dr. M.P. Jain, sir. Not there. Professor Parag Ratnakar Gogate, sir. Srimati Sheila. सब लोग हैं, सब लोग. Professor K.S. Rajanandam, sir. Professor Asit Kumar Saha, sir. Mr. Dhaval Saxena, sir. अरे 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 अरे.
স্যার আপনি নিয়েছেন এসকে রায় স্যার রায় স্যার
हाँ यस Mr. Praveen Saxena, sir. Dr. M. Srinivas Rao, sir. Dr. M. Srinivas Rao, sir. He's not there. Mr. Thakur Sunil Indulal, sir. आ रहा है सर बेटा वहीं पे होगा हाँ सब कुछ बना हुआ है सर हाँ यस सर यस कार्तिकेयन सर हाँ यस और कोई बचा हाँ बाद में हो जाए
So now we will be handing over the past the President 2022 medal by the President elect designated. So I am requesting Professor Karthikeyan sir to hand over the President 2020 medal to Mr. D.M. Butalaji. Yes, yes. Wait.
कोऑर्डिनेटर हैं जिनके हैं
So now I'll put the vote of thanks formally on the behalf of council. उसका बाद में फिर
Central Power Research Institute, Bangalore. I thank Dr. Pranav Chaudhary, technical sessions, and the entire team. They did excellent work. And I thank Dr. Shravan Kumar, Travel, and that entire team and their volunteers. They did excellent work. And with this, they required a big applause from all of you. Thank you.
So now, yeah, you want to, please.
Myself Yash Mishra from final year chemical engineering NITK, and I like this Chemcon very much. Like in the my NIT also so many events happen, like incident which is biggest event, but like the participation of the volunteers is not like this much. Like in this chemical participants or chemical students only participated, and that was big than the numbers in which my college participate in that event. Like some politics happen or some other things, so because of which very less participation is there, but the volunteer participation in this was very much. And like my home is here only, so in the corona that my NIT was closed, so I used to come here and like play in that field and all. In the like when I was small also, then that field was open for like outsider also, but so I used to play there. And I used to attend that from Radhakrishnan auditorium some events in the corona also, when my college was closed, and in the morning also I used to come and run in that field. So thank you.
Thank you. So, madam, please.
Good evening, one and all present here. I am Sri Aarti, research scholar from Anna University. Actually, they'll tell like hereditary is something you just carry the information from one generation to the another generation. But these people, being a mentors and an inspiration, they are like transferring the information, what the research they have done in their generation to us. So this is very much feel inspired and motivated, so that we have to do many research by following these peoples. And one more thing is the hospitality and the accommodation, the facility, what they done to us is very much inspired us and great. And Sastri sir and Karthikeyan sir are all like good mentors, so just follow them. And but I don't know other sirs, so sorry, excuse me. But really very happy to be a part of this event, and I just feel motivated and inspired. Thank you so much.
So, thank you. Now we come to end. Yeah. Okay. Rakesh ji. Rajkumar, sorry.
Myself, Dr. Rajkumar Kushwaha. I am serving here from July. I am one of the organizers that is heading the registration team. So this is my 5th Chemcon that I am part of it. 2 that I have in 2 that I have attended in Kolkata, in Chennai, 1 I have attended in Guwahati, and 2 I have been part of the student organizing team headed by Dr. M.K. Jha. One thing that I have liked about that, earlier that I was the part of the team, MTech and PhD scholars were heading that team. But here, 2nd year and 3rd year, and some of the final year students were there. They don't have any obligation to us because they have done their really wonderful job. Being part of the organized team, I really like to thank them because they have shown that much dedication. They have, from the accommodation team, from the registration team, all that students have shown dedication because they have some respect to us. So I really like to thankful 3rd year, final year, and all the students that have been member of that particular organizing team. Can you clap for yourself, please? Thank you.
So, thank you. Yes, madam. Short.
She is there. A very good evening, ladies and gentlemen. I request all the dignitaries to please come up on the dais and take a seat. So I don't have the list of the dignitaries, so I've just... Okay. Should I take the name of the dignitaries? They are seated already. कौन? ओके ठीक है वो नहीं है ओके स्टार्ट करूँ A very good evening, all of you. I'm Mudita Mishra, your host for the evening. Every good occasion has an end, but the legacy continues. I'm sure all the delegates, research scholars, foreign speakers, and students of HBTU had an enjoyable feast of knowledge throughout the last few days of grueling technical sessions and engaging interactions. There were 25 eminent speakers from US, Canada, Japan, and Europe. Apart from learned professors and industry experts who spoke on the occasion on a variety of subjects like sustainability, digitalization, artificial intelligence, green chemistry, renewable energy, and hydrogen and biofuels. We are fortunate to have them speak on research going on in their respective areas. We also saw one of the largest participation of technical papers and research scholars representing technical institutes or universities from all over the country or abroad. In a nutshell, this Chemical Engineering Congress has set a superlative benchmark in the history of Indian Institute of Chemical Engineers, where 2 new memorandum of understandings were signed between IICHE and Society of Chemical Engineers, Japan, and Canadian Society of Chemical Engineers. On this note, I would like to request Professor R.K. Trivedi Sir, Chairman of Local Organizing Committee, Chemcon 2022, to give his welcome address and a brief report of Chemcon 2022. Okay, sir. I would like to request all the dignitaries to please light the lamp.
Honorable Bhanu Pratap Singh Ji, Chief Guest of this function, Minister of State, MSc, Government of India, Sri Rajkumar Lohia Ji, Guest of Honor, Managing Director of Lohia Corp, Lead Industrialist in Kanpur, Professor Shamsher, Vice Chancellor of HBTU, DM Butala Ji, President IICHE, Mr. B. Chattopadhyay Ji, Chairman of National Organizing Committee Chemcon 2022, Dr. Abhijit Ghosh, Honorary Secretary IICHE, Dr. SVR Shastri, Organizing Secretary Chemcon 22. Invited dignitaries, ladies and delegates, exhibitors, and guests and faculty members of the university, student representative of media. It gives me great pleasure to extend a most hearty and cordial welcome to you all in the valedictory session of this conference on sustainability in chemical process through digitization, artificial intelligence and green chemistry, which has been the theme of this Chemcon 22, which have been deliberated last 4 days. We are indeed honored to have Sri Bhanu Pratap Singh Ji, Minister, Government of India, to be the chief guest of this evening. I welcome him on my own behalf and as Chairman LOC and on behalf of Organizing Committee of Chemcon 22. I'm sure he is going to enlighten us with the industry leaders' perspective and Government of India perspective. I'm sure that message will be guide to all of us and students in particular. I extend a very warm welcome to Sri Rajkumar Lohia Ji, who is also guest of honor of this function. His view will be again very valuable as they will be coming from a veteran industrialist. I also welcome distinguished members of National Council members and members of Chemcon 22. I also welcome all speakers and chairman of the various sessions of this conference and distinguished delegates. I especially welcome the student participants of this conference who have come here from across the country. I also welcome the representative of print and electronic media, press who have made it to be here and at this function and gave a very wide coverage since last 3 days in the important newspapers. The faculty members of HBTU and other institutions, IICHE members of Kanpur Regional Center and guests I also welcome who have made this valedictory function a graceful occasion by their presence. Last 4 days, we have listened to industry, corporate leaders, senior faculty members, speakers from Japan, US, Canada, and other parts of the country. The conference has provided ample opportunity to professionals of chemical engineering and technology and chemical industry at large to share their experiences, exchange ideas with industry peers and academic researchers. This event has served as a forum for sharing knowledge and experiences among industry peers, academic researchers and learners, especially students who want to develop their career in these specialized fields. The session of Shastri Indo-Canadian Institute has provided several information and opportunity for Indian students and faculty members for exchange program. In fact, Shastri Institute is a joint program by Government of Canada and Government of India. I am happy to inform you that the purpose of this conference was deliberated, all the stakeholders, and come out with some tangible suggestions, recommendation, which will be framing recommendation and submitting to government and other stakeholders for implementation. Those have been formulated. With these words, I once again welcome you all and wish all success of deliberation of this conference. Jai Hind, Jai Bharat.
Thank you, sir. I would like to request some of the delegates to please come up on the stage and share their response and comments towards this 4-day chemical conference. Talent and skills are the crops that are nurtured, groomed, and given all the possible opportunities to grow and bloom. This is a much awaited event in every student's journey for this mega conference. Oh, you want to speak? Sure.
Good evening, everybody. To all the dignitaries, thank you, sir. Actually, I'm Sri Ati from Anna University, Chennai. This event after the pandemic, it was a very great event, and the organizing people and the hospitality and the students and all the knowledge and information we have gathered from this conference is very much useful. So with this new year, we carry something like very big for our future perspective. So I just really thank all the organizing committees and the members for this successful event. And really, we'll tell all our students to join the 2023 Kolkata event also. Thank you so much.
Thank you so much. Would anyone else like to come up on the stage and speak? Okay. Talent and skills are the crops that are nurtured, groomed, and given all the possible opportunities to grow and bloom. This is a much awaited event in every student's journey in this mega conference, as it gives the returns to the efforts put in by them throughout their academic endeavor during this Chemical Engineering Congress. It is a moment full of joy, a moment about pride and accomplishment, a moment of celebration. It gives a sense of achievement and a sense of responsibility towards fulfilling their further commitments. Thus, it's time for the distribution of certificates to the students. I would like to request our guest of honor, respected Mr. Rajkumar Lohia Sir, Chairman and Managing Director of Lohia Group, to please distribute the prizes to the students. First, for the oral presentation, we have Rahat F. Momin as the first prize and Chintalapudi Nagalakshmi on the second prize. For wastewater treatment. So, but I don't have the names of the other presentations. Is Rahat F. Momin or Chintalapudi Nagalakshmi here? Somebody else who wants to receive it on their behalf? Next, for the presentation 2, we have Sanjay Ghosh and Kapil Khandelwal.
So I request Mr. Gaurav sir, the Faculty of Oil Technology of Chemical Technology branch, to receive the prize on behalf of the student. parallel session 1, parallel session 2, parallel session, ऐसा बोलिए.
So what?
PS1, parallel session 1, parallel
Okay,
session
sir. Sir, I've got the names.
2. और सब में एक को बुलाइए पहले, दो को मत बुलाइए. First prize, second prize. Dr. Sanjay Ghosh is IIT Roorkee.
So is he here?
For parallel session 2, from the theme of biomass utilization and bioenergy, on the first prize we have Dr. Sanjay Ghosh sir,
IIT Roorkee.
IIT Roorkee.
Request Dr. Rajkamal Kushwaha sir to please come and collect the prize on behalf of Professor Sanjay Ghosh.
On the second prize we have Kapil Khandelwal sir. For parallel session 3 on nanotechnology and nanoscience, the first prize goes to Mr. Omkar Singh Kushwaha.
Faculty में तो इसका नाम बोलिए.
For the second prize, I call Dr. Vinita Gautam ma'am.
Faculty of Oil Technology, HP2 Kanpur. Dr. Vinita Gautam.
For parallel session 4 of theme modeling and stimulation of processes, the first prize goes to Dr. D.V. Padma ma'am. The second prize goes to Mr. Pankaj Kumar Gupta sir. For parallel session 5 of the theme renewable and alternate energy, the first prize goes to Vishwas V. Deshpande. I would like to request Dr. Dan Bahadur sir to receive it on his behalf. He's here, okay. The second prize goes to Ashish Gautam. Sir. For parallel session 6 of the theme Catalysis and Reaction Engineering, the first prize goes to Lomas Rishi. The second prize goes to Kaushal Kishore Singh. For parallel session 7, the first prize goes to P. Prem Sagar. The second prize goes to Dr. Satyabrata Mishra. For parallel session 8, the first prize goes to Roshni Kumari. The second prize goes to Manoj Udasi. Okay. For parallel session 3, the second prize goes to Dr. Vinita Gautam. For parallel session 9, the first prize goes to Dr. Lakshmana Nayak Ramavathu. The second prize goes to Utsav Dalal. For parallel session 10, the first prize goes to Marvi Kaushik. The second prize goes to Gitanjali Bhati. With this, we come to the With this, we come to the end of prize distribution for oral presentation, and we move on to the prize distribution of poster presentation. On day 1, the first prize goes to Chandrika Sengar. The second prize goes to Vaishali Ajagiri. On day 2, the first prize goes to Sunita Paletti. Second prize goes to Mr. Govind Madhav. For day 3, the first prize goes to Mr. K. Yeshu Ramya. The second prize goes to Monali Priyadarshini. For day 4, the first prize goes to Smriti Dwivedi. The second prize goes to Chandrasekhar Rathore. I would like to request the dignitaries to please distribute the mementos now to our faculties. First we have Professor Rakesh K. Trivedi Sir, Chairman of Local Organizing Committee, Chemcon 2022. Shri Bishwanath Chattopadhyay Sir, Chairman of National Organizing Committee, Chemcon 2022. Dr. S.V.A.R. Shastri Sir, Organizing Secretary of Chemcon 2022. Professor Rakesh Katiyar Sir, Convener of Local Organizing Committee. Dr. Avijit Ghosh Sir, Joint Convener of National Organizing Committee. Dr. Ashutosh Mishra Sir, Joint Organizing Secretary and Treasurer. Mr. Gaurav Singh Sir, Executive Secretary of Chemcon 2022. Professor S.K. Gupta Sir, Organizer of Technical Committee. Dr. Shravan Kumar Sir, Accommodation and Transportation Coordinator. Dr. Zeenat Arif Ma'am, Stage Management and Coordinator. Dr. Rajkamal Kushwaha Sir, Registration Coordinator. Dr. Ashish Kapoor Sir, Technical Session Coordinator. Dr. Adarsh Kumar Arya Sir, Coordinator Chemcon 2022. Dr. Pranav Chaudhary Sir, Technical Session Coordinator. Dr. Dan Bahadur Pal Sir, Souvenir Coordinator. Dr. Anjali Avasthi Ma'am, Certificate Coordinator. Dr. Benita Singh Ma'am, Cultural Events Coordinator. Dr. Vinay K. Sachan Sir, Convener of Local Organizing Committee, Chemcon 2022. Thank you so much. I would like to request the dignitaries to please take their respective seats. I would like to request Mr. Vishwanath Chattopadhyay, Sir, Chairman of National Organizing Committee Chemcon 2022, to deliver his speech.
I have not started, the alarm is ringing. Shut it down. Chief guest of the evening, Honorable Minister of State, MSME, Government of India, Sri Bhanu Pratap Singh Ji Verma Ji. Guest of honor, respected Sri Rajkumar Lohia Ji, Chairman and Managing Director of Lohia Group, Kanpur. Esteemed Vice Chancellor of Harcourt Butler Technical University, Professor Samses Ji. President IICHE, Sri DM Butala Ji. Honorary Secretary, Dr. Avidit Ghosh. Local Organizing Secretary, Local Organizing Committee Chairman, Professor R.K. Trivedi. Organizing Secretary, Dr. S.B.A.R. Sastri. Ladies and gentlemen. It gives me immense pride and pleasure that the Chemical Engineering Congress, Chemcon 2022, organized by Kanpur Regional Center of Indian Institute of Chemical Engineers, has been successfully conducted with much triumph at Harcourt Butler Technical University. There are many milestones achieved in this Chemcon, starting with an exhilarating and motivation-embedded message from the chief guest of opening ceremony, Honorable Chief Minister of Uttar Pradesh. Let this Chemcon be the first stepping stone for his dream and vision of making Uttar Pradesh an epicenter of chemical industry in India. Chemcons come and go, but what remains and carries on is the legacy of a well-conducted event that resonates with every chemical engineer's mind for years to come. We have been working on this Chemcon for last 1 year relentlessly. My office at Calcutta virtually became a de facto Chemcon 2022 office, and I would like to thank my dear secretary, Ms. Mausumi Bhaumik, for sending thousands of letters, emails, correspondences from my desk. I am grateful to the Vice Chancellor of HBTU for his all-round support and guidance to make this Chemcon 2022 a resounding success. He has been instrumental in energizing the spirit of HBTU. Please, can you be silent, please? He has been instrumental in energizing the spirit of HBTU. I sincerely wish we all stakeholders of HBTU, I am also an alumni of 1980 class. So we all stakeholders of HBTU must work constructively to bring back the glory of chemical engineering education in HBTU. We have accomplished many milestones in this Chemcon. There were 2 speakers from Europe, 4 from Japan, 7 from USA, 10 from Canada. It was a good occasion when members of USA and Canada team interacted with faculties of HBTU to start a more meaningful academic relationship. This is the opportunity which HBTU should not let it pass. This is my request to all. 2 memorandum of understanding were signed between IICHE and Society of Chemical Engineers Japan and Canadian Society of Chemical Engineering. MOU with American Institute of Chemical Engineers will also be renewed very shortly. It is the responsibility of IICHE to work on these MOUs and make it more participative through a dedicated cell. This is my suggestion to IICHE, that you should form a dedicated cell who can coordinate. MOU can be signed and thrown into the paper basket, but you should have a dedicated cell where more participative, more exchange of views, more exchange of papers. Our people can go there in their seminars, and they can come here and make it more interactive and exchange of learning process. There were extremely engrossing discussions throughout these 4 days. Speakers after speaker spoke on sustainability, net zero transition, renewable energy, recycling of plastic waste, digitalization, artificial intelligence, green fuels, and chemistry, and other chemical engineering subjects. I am sure all participants enjoyed their speeches, and are heading home with more insights and knowledge. There were 3 joint symposiums with speakers from Canada, USA, and Japan. This was probably the best thing that can happen in the 75th year celebration of IICHE. Messages from the presidents of Fraternity Institute from USA, Canada, Europe, Japan, UK made the celebration more vibrant and memorable. It is the first time that American Institute of Chemical Engineers had given their consent to become co-sponsors of Chemcon 2022. I profusely, a big round of applause for AICHE. They say that it is the global home of chemical engineers. I profusely thank my friends in the industry for extending financial support. Without them, we couldn't have organized such massive conference. I must thank every individual connected to this conference for making this event a grand success. Let the ecstasy and euphoria, the spirit and motivation of Chemcon 2022 continue to inspire us for times to come. I will quote Spencer Hartcut Butler when he gave a speech in 1921, November 5th, when he founded this institute. He said, "This institute may thus be said to mark an ultimate sociological as well as immediate industrial idea. The institute will have 2 sides. One is instruction, the other is research. They must operate and energize together. This is how the accepted view. Let our motto be on and ever on." Let that motto resonate to your ears of HBTU students, that it should be on and ever on. With these words, I conclude my speech. Thank you all for giving me a patient hearing. Thank you and namaskar.
Thank you so much, sir. I would now like to request Dr. Avijit Ghosh, sir, Honorary Secretary of IICHE, to give his address.
Respected Chief Guest, Sri Bhanu Pratap Singh Verma ji, Honorable Central Minister of State, MSME. Guest of Honor, respected Sri Rajkumar Lohia, Chairman and Managing Director, Lohia Group. Professor Samser, Vice Chancellor, Hartkot Balda Technical University, Kanpur. President, Mr. D.M. Butala. Mr. Vishwanath Chattopadhyay, Chairman, National Organizing Committee. Professor R.K. Trivedi, Chairman, Local Organizing Committee. Dr. S.V.A. Sastry, Organizing Secretary, Chemcon 2022. Other dignitaries of the dais, council members, participants, good evening to all of you. This is my 3rd Chemcon, being Organizing Secretary. I am attending and delivering the lectures for the council, on behalf of the council and the Indian Institute of Chemical Engineers. In short, what I would like to emphasize on that, the programs you have already witnessed. Such a big program without the help of the host institute, unconditional host, it is not possible. So, a thanks to the Vice Chancellor of HBTU University for extending his all-out support to make this event a grand success. Thank you, sir. On the behalf of IICHE, we extend our heartfelt thanks for your kind cooperation. IICHE did 2 annual programs throughout the year. One is Student Chemical Engineering Congress, one is the Chemcon. The Student Chemical Engineering Congress held in the month of September and Chemcon in the December. This is our annual event and date is fixed. Through these 2 programs, what we did basically, we used to connect the chemical engineering professions across the world. Lot of chemical engineering or other allied disciplines are participating in this conference, and our IICG family is growing day by day. I am happy to mention that at present we had a 32,000 plus members in all categories. So which is a second highest professional members after Institute of Engineers India. We had a membership drive. You can visit our website. Not only chemical engineer, other engineering discipline students can also become a member after require experience. Like a mechanical engineer, electrical engineer can become our live member after graduating within 3 years. Once they acquire certain knowledge in the field of chemical engineering area, they are eligible. So those are non-chemical engineering are participating. I am requesting you kindly visit our website to become a member. One important announcement I would like to share here. The BTech in chemical engineering students, after graduating from the current year, you will be eligible to become a member within a 1500 rupees only for life, which was earlier 7,000. So council in 75th years has taken a resolution. We had to reach to our students. Those will be our backbone, and they will carry forward the legacy of the Indian Institute of Chemical Engineers. So I request all the students, please become a member within the first year, because as you take more year, their fees will increase, and after 5 years it will again restore to 7,000. So instead of paying 7,000, you pay 1,500. So this information I would like to share. Apart from whatever the events we are doing throughout the year, training program, certificate program, collaboration, internship, other activities, everything we are reaching to our members through different mode of communication. And I can share the another information. The IICH is the only professional body who is having a app. If you visit our website, no other professional body, they don't have any app. We had a IICH app. You can download, you can get it connect to 24/7 with us. And our office is very much supportive. Thanks to all the headquarter employee. Throughout the year, they are putting their very hard work to communicate with all the members across the world, because we had a overseas member also. Now, yesterday we opened overseas chapter, regional center, but earlier that we had a overseas member. Those are working at Canada, Dubai, others United States. They are also our member. This is one request to all the participants, those who are not member, you can connect, because being a chemical engineer, you will be forever chemical engineer. So this is a great platform, and I just share my feelings about this Chemcon. On the day one, I am associated with Mr. Chattopadhyay ji. Not only we came here time to time to see the infrastructure and other arrangement, but also we used to sit very frequently at Kolkata headquarter office and spend many hours to sort out and make the program should be a grand success. And with his esteemed guidance, today I can say it has grand success. Thank you, sir, Chattopadhyay sir, for your great vision. And he only used to dream that HBTU having one IICH building. And I am happy that Vice Chancellors are already committed that they will be allotting some space and there will be IICH building. So it will be proud for IICH Council that we have only 6 center, those are having a building, but Kanpur is going to enter those the class. So once again congratulated to the Trivedi ji also, and because he also used to see that we should have one building. So thank you very much for helping IICH, not helping the any particular, helping IICH to conduct his annual session at HBTU. Thank you all.
Thank you so much, sir. Now, I would like to request Mr. D.M. Butala, sir, the President of IICHE, to address the congregation.
Good evening to all. Honorable Central Minister of State, Sri Banu Pratap Singh Verma ji, the chief guest of our today's function. Chairman and Managing Director of Lohia Group, Sri Raj Kumar Lohia ji. Vice Chancellor, HBTU, Professor Samser ji. Sri Biswanath Chattopadhyay ji, Chairman, NOC Chemcon 2022. Professor Dr. R.K. Trivedi ji, Chairman, LOC Chemcon 2022. Dr. Avijit Ghosh, Honorary Secretary, IICH. Dr. S.V.A. Sastry, Organizing Secretary, Chemcon 2022. At the onset, let me begin with, as we are on the last day of the 2022, I wish you all, because tomorrow's morning sun will be entering the new year. So let me wish you all a very happy and bright, prosperous 2023, and let the new year bring a very good laurel and good luck to all of us. And we all, as it is said that the COVID is spreading all over the world, I wish we all take the requisite precautions and we are all saved from the COVID. IICHE started its journey on 18th May 1947. Journey continued, and as a part of the journey, we had various stations called Chemical Engineering Congress, Chemcon. Chemcon 2022 is the 75th milestone of this journey where you have come to, and I am indeed really very much thankful to the Vice Chancellor of HBTU, who wholeheartedly gave the full support. In the month of the June, I was here, and I am indeed very happy. My meeting with him was a really unforgettable meeting, which made and which showed the light of today as we are all here. Chemcon 2020 theme, sustainability, artificial intelligence, digitalization and green chemistry. Friends, I would like to say one thing. Chemical engineering saved the world. I will go with one step ahead. With the implementation of artificial intelligence, digitalization and applications of green technology, we chemical engineers are going to save not only our nation, we are going to save the Indian chemical process industries, as it is going to play a big role. Chemcon 2022, we had a very, as Sri Chattopadhyay ji mentioned, where we had a very unique steps, which has put up, which is going to be a very long way in the chronicle of IICHE. Joint MOUs, particularly AICHE, who has come for the first time to have a joint symposium with the Indian Institute of Chemical Engineers, AICHE. I am also incidentally member of AICHE, and they saved the world, and they are the global founder. And in the domain of chemical engineering, AICHE plays a big role. I am sure with the deliberations we had here in all the 4 days, this is going to put up a very interesting chapter in our Indian history, and IICH, particularly IICH, which will be playing a very important, crucial role for molding up the younger generation, that is the millennial students, and the batons which is being passed by the young people like me. We are aged, but I say we are young, and the millennial students are the younger generation who will carry the message and will go ahead. I take this opportunity to thank the entire team of Sri Chattopadhyay ji, as well as Sri R.K. Trivedi, and all the other people and the student, particularly student volunteers, who have put up tremendous efforts. They have not left any stone to be turned to make this event successful. And the mega event of IICHE has come to a really great success, and this is not a full stop. We are going to meet once again at Kolkata for the Chemcon 2023. Thank you all.
Thank you so much, sir. Moving on, I would like to request Professor Shamsher sir to please address the crowd.
Good evening to all of you. Chief guest of the today's function, respected Sri Bhanu Pratap Singh Verma ji, Honorable Minister of State for Micro, Small and Medium Enterprises, Government of India, our guest of honor Sri Rajkumar Lohia ji, CMD of Lohia Group of Industries, Dr. D.M. Bhutla ji, President of Indian Institute of Chemical Engineers, Dr. Avijit Ghosh, Honorary Secretary of IICHE, National Organizing Committee Chairman, Dr. Vishwanath Chattopadhyay ji, Professor Trivedi, Chairman of Local Organizing Committee, Dr. Sastri, Organizing Secretary of this conference, Member of IICHE, awardees, delegates, and participants from India and abroad, faculty members and students of the host and co-host institutes, exhibitors, media persons, ladies and gentlemen, good evening to all of you. It gives me immense pleasure to be here with august gathering of chemical engineers traveled a long way to attend this conference. I thank all the faculty and students of Harcourt Butler Technical University, IIT Kanpur, CSGM, AITH, APJ Kalam University, Rajiv Gandhi Institute of Petroleum Technology, Amethi, who have extended all support to IICHE for organizing these events with great success in the premises of HBTU. The theme of Chemcon 2022, Sustainability in Chemical Processes through Digitization, Artificial Intelligence and Green Energy, Green Chemistry, is very relevant in the present scenario of digitization, machine learning and artificial intelligence. I hope that during these 4 days of completely packed sessions, the participants might have got clarification to their doubts and issues in their minds. They might have explored to new research areas to work in sight of many relevant issues like efficiency of EVs, weight reduction of EVs, batteries, waste disposal, especially agriculture, which the India is facing a lot and creating a lot of pollution. Its conversion techniques to biofuels and other useful products, plastic and municipal waste and other hazardous waste, zero waste recycling, biofuels, renewable energy, bioeconomy, circular economy, solar power, new and composite materials, water treatment, conversion of non-biodegradable plastics to biodegradable plastics, and many more. The new collaboration and connects between the national and international delegates that has established among the participants during these 4 days of the interaction, the quality of research in the time to come will certainly improve and benefit the nation and humanity at large. I congratulate the organizing committee members for their hard work for conducting this conference successfully. And I'm also really thankful to the IICHE for selecting HBTU and giving us opportunity to host this great event. With these words, I wish all the present here a very happy and prosperous New Year 2023, which is just a day away. Thank you very much.
Thank you so much, sir. I would like to request our honorable guest of honor, Shri Rajkumar Lohia sir, Chairman and Managing Director of Lohia Group, to give his speech.
Hari Om. Good evening. Honorable Chief Guest, Shri Bhanu Pratap Singh Verma ji, Honorable Minister of State for MSME, Government of India, Professor Shamsher, Vice Chancellor, HBTU, Mr. Vishwanath Chattopadhyay, Chairman, National Organization Committee, Mr. Butala, other honorable dignitaries on the dais, distinguished speakers, delegates, students, ladies and gentlemen. I am indeed thankful and extremely grateful to be honored for inviting me for the validity session of this August seminar as guest of honor. HBTU, where we are all standing, was HBTI before, established as one of the premier technical institutes focused on chemical engineering in 1921. It is more than 100-year-old and perhaps the first institute in India focusing on chemical engineering with plastic as a focus. Has contributed immensely towards the advancement of country in the field of chemical engineering. Chemical engineering has played a vital role in development of the world. Our body, our brain, that's all made of different chemicals. Many important elements of chemical engineering is petrochemicals, extraction of metals, pharmaceuticals. Think of handling COVID if there was no chemical engineering. The pandemic, the last two pandemics have seen that the advancement of chemical engineering has played a very, very vital role and a very pivotal role in handling of this massive natural disaster. With the help of chemical engineering in the form of pharmaceutical development and medicines, has increased the life expectancy from 1950 to 45 years in 2022 to 72 years. Today, the agriculture production has quadrupled in last 50 years, and that is all thanks to chemical products in form of fertilizer. The world would have gone without food if there was no advancement and development in chemical processes. The time of digital economy, digital development is very much here. I, as a machinery producer, have seen the advancement in production technologies, design improvements with the help of digital world. I'm pretty positive that the future development of chemical and chemical engineering will be based on digital innovation. Since there are many students, I have special messages to them. The society invests extensively in developing engineers. India remains one of the cheapest education system for engineering. The quality of engineering education in government assisted colleges is way above than the private colleges. Sorry? Okay. Is way above the private engineering colleges. We as the company always look that if we can get students from the government engineering colleges. What pains me extremely when I see an engineer coming from the engineering college which are assisted by the society, looking for jobs outside engineering or looking for the work outside engineering space. this is, I am begging apologies for using a harsh word. It's cheating to the society. When an engineer applies or aspires to become a bureaucrat, aspires to become a banker, aspires to become a salesman of consumer products, these are not the role for engineer. Becomes a non-engineer in its profession. He is depriving somebody who would have filled that seat in the entrance exam and served the nation as engineer. It is also the responsibility of the engineers, especially in the chemical engineering, that work in a manner which gives sustainability, which gives quality. The recent incident, I think yesterday in Uzbekistan, is the failure of perhaps the company which produced the product. But it is also the responsibility of the engineers who were involved in that production process. It was their lapse. So, an engineer or any professional, when works for a company, has dual duty to be honest to the company where he is working, but also to the honest the profession he is entering in. You don't have to follow blindly the orders given. He has to scratch his conscience and to see that everything which is happening is as per ethics of the work. It is often said that engineers are not well paid. I think this is anything far from truth. I can give you an example of my company where a 10-year-old engineer who qualified just 10 years back in science and did his PhD in plastics is paid 2 crore rupees per year. So, if country produces the engineers which are world class and they stay in India, they will also earn the salaries which are parallel to anywhere in the world. The unfortunate part is that the topmost of the engineers, they choose not to remain engineers. Majority of them. There would be exceptions, of course. They are either entering IS services or going to IIM and becoming bankers. This is very, very unfortunate. Nowhere in the world this happens. Or they choose to study from the institutes who are served by the Indian society and go to countries abroad and serve that society. It is shameful. It is dishonesty. Yes, you can go to a private college, pay that fees, do whatever you like. But don't milk society for your own benefit. There are adequate examples of engineers excelling in chemical engineering space. Mukesh Ambani, who set up the petrochemical complex under the, of course, guidance of his father, is today richest Indian. And he is a chemical engineer. There is a very, very high demand of engineers. I am, as an employer of maybe 200 engineers, can tell you that we struggle to get good engineers. And we will not shy paying the best of the salaries. This problem is very, very high in North India. When we go to South, this problem is much less. Imagine, I am sitting in West, we are talking in Kanpur, which house one of the 2 most prestigious institutes, HBTU and IIT. And we have shortage of engineers. Why? Having said all that, I must admit that India has a huge potential for growth in chemical industry. You would all have been hearing China plus one strategy. China has been a major supplier of chemicals to the world. It's India's turn to take that position. It is your job to make it happen. We have today a plastic consumption of 20 kgs per capita, as against world average of 55. And while it is said plastic is evil, but we can't live without plastic. Plastic is not evil. The recycling, plastic is a product which must be recycled. And development of recycling technology is necessity which engineers have to address. Having said all this, and sorry for some words which are very straight, I meant no evil. In my age of 70, I have the, let's say, authority or responsibility to set guidelines for the young people like you. I wish you all best. Thank you very much.
Thank you so much, sir, for your kind and encouraging words. Further, I would like to request Shri Ashish Patel, sir, Honorable Minister of Technical Education. Okay. I would like to request our chief guest, Shri Bhanu Pratap Singh Verma, sir, Honorable Central Minister of State, MSME, to enthral us with his kind words.
विशेष रूप से चाहूँगा चूँकि इस देश के यशस्वी प्रधानमंत्री नरेंद्र भाई मोदी जी की माँ हीराबेन का आज ही रात में उनका देवसान हुआ था। देश के यशस्वी प्रधानमंत्री जी ने उनका अंतिम संस्कार करने के बाद जो भी कार्यक्रम थे वो किए हैं और हम सबको भी निर्देश दिए गए थे कि जहाँ जो भी हों, जिस कार्यक्रम में जहाँ जो जा रहे हों वहाँ पहुँचें। तो मैं चाहूँगा यहाँ सभी लोग जो बैठे हैं उनकी आत्म शांति के लिए 2 मिनट के लिए शायद मौन रखेंगे तो हम लोगों को अच्छा लगेगा। ओम शांति शांति शांति। आज HBTU के इस सभागार में केमकॉन (2022) केमिकल इंजीनियर कांग्रेस एवं इंडियन इंस्टीट्यूट ऑफ केमिकल इंजीनियर्स के 75वें वार्षिक सत्र के अवसर पर आयोजित कार्यक्रम में मंच पर उपस्थित आदरणीय श्री लोहिया ग्रुप के चेयरमैन श्रीमान राजकुमार लोहिया जी, HBTU के वाइस चांसलर श्री प्रोफेसर शमशेर जी, IICHE के प्रेसिडेंट श्री DM बुटाला जी, LOC के चेयरमैन श्री प्रोफेसर RK त्रिवेदी जी, NOC के चेयरमैन श्री विश्वनाथ चट्टोपाध्याय जी, ऑर्गेनाइजेशन के सेक्रेटरी जी, यहाँ हमारे साथ आए हुए भारतीय जनता पार्टी के कानपुर देहात के जिलाध्यक्ष आदरणीय श्याम सिंह सिसोदिया जी, हमारे साथ आए हुए कैलाश मिश्रा जी, अन्य साथीगण, इस आयोजन को सफल बनाने में जिस टीम ने 4 दिन काम किया और यहाँ उपस्थित हमारे प्यारे बच्चों, विशेष रूप से आज मैं सुबह यहाँ आ गया था, लेकिन मुझे मालूम था कि 27 तारीख से 30 तारीख तक ये कार्यक्रम यहाँ किया जा रहा है और विशेष रूप से हमारे प्रदेश के मुख्यमंत्री जी को यहाँ आना था उद्घाटन सत्र में, और मुझे भुवनेश्वर रहना था, इसलिए आपकी सेवा में उस समय उपस्थित न हो सका। लेकिन हमारे जो मुख्यमंत्री जी हैं, उन्होंने वीडियो कॉन्फ्रेंस के द्वारा अपना संदेश आप सबके बीच सुनाया गया होगा, और विशेष रूप से मैं जानता हूं उनके प्रतिनिधि के रूप में जो अवनीश अवस्थी जी हैं वो भी यहाँ आए होंगे, उन्होंने अपनी बात रखी होगी। और निश्चित ही जो हमारे जो बाहर से लोग आए हैं, जिसमें हमारे भारत के साथ साथ जापान, यूरोप, कनाडा, अमेरिका सहित अन्य देशों के महान वैज्ञानिक, उद्योगपति और अधिकारीगणों ने यहाँ भाग लिया है। उन्होंने निश्चित इन सभी से अनुरोध किया होगा कि उत्तर प्रदेश में आकर वो अपना उद्योग लगाएं और उत्तर प्रदेश की धरती पर उन्हें वो सारी सुविधाएं प्राप्त होंगी जो वो चाह रहे हैं। क्योंकि देश के यशस्वी प्रधानमंत्री नरेंद्र भाई मोदी जी ने 2025 तक हमारे उद्योगपतियों से और अन्य विख्यात लोगों से आह्वान किया है कि हमारी जो अर्थव्यवस्था है उसे हम $5 ट्रिलियन तक हमें 2025 तक ले जाना है, और उसी के तहत उत्तर प्रदेश भी उसी योगदान में अपना 25% का योगदान करीब $1 ट्रिलियन के योगदान के लिए आह्वान उत्तर प्रदेश सरकार ने किया है। विशेष रूप से मैं भी कहना चाहता हूं कि देश के यशस्वी प्रधानमंत्री जी वो सारे काम कर रहे हैं जिन कामों के माध्यम से देश की प्रगति हो और हमारे जो उद्योग धंधे हैं वो और फलें फूलें। चूंकि देश के यशस्वी प्रधानमंत्री जी ने मुझे एमएसएमई मंत्रालय का भार सौंपा है, सूक्ष्म लघु और मध्यम उद्यम मंत्रालय, मिनिस्ट्री ऑफ माइक्रो स्मॉल एंड मीडियम इंटरप्राइजेस। उसमें जितने भी हैं छोटे छोटे धंधे, उनके माध्यम से एक नए भारत की स्थापना करने के लिए देश के यशस्वी प्रधानमंत्री जी प्रयास कर रहे हैं। और निश्चित ही हम कह सकते हैं कि बड़े बड़े उद्योगों के साथ छोटे छोटे हमारे एमएसएमई के भी लोग उसमें काम कर रहे होंगे। आज की स्थिति में अगर हम लोग देखें तो हमारा जो एमएसएमई है वो करीब 6.3 करोड़ एमएसएमई कार्य कर रहे हैं। और इन 6.3 करोड़ में करीब 11 करोड़ लोगों को रोजगार मिला हुआ है। और उसी हिसाब से हम देखें देश की जो जीडीपी है, उस जीडीपी में एमएसएमई का योगदान करीब 1/3 का है। और जब हम देश का निर्यात के बारे में बात करते हैं तो हमारा देश का जो निर्यात है उसमें एमएसएमई का योगदान लगभग 50% के करीब है। एमएसएमई सेक्टर ये ढेर सारी योजनाओं के माध्यम से समाज के बीच काम कर रहा है। और उन्हें कुछ योजनाएं ऐसी दी हैं जिन योजनाओं के माध्यम से हमारे बच्चे चाहे इंजीनियरिंग क्लस्टर बना सकते हैं। और वो सीडीपी इंजीनियरिंग क्लस्टर जिसमें 30 करोड़ रुपए तक का योगदान प्राप्त होता है, 20 से 30% उसमें स्टेट का योगदान है, 10% एसपीबी का है और करीब 70% जो पैसा है वो केंद्र सरकार देती है। और उसके माध्यम से कि अभी जो क्लस्टर बने थे करीब 89 क्लस्टर बनाए जा चुके हैं, जिसमें 9 इंजीनियरिंग क्लस्टर हैं। 105 क्लस्टर और बनाए जा रहे हैं, जिसमें 14 क्लस्टर इंजीनियरिंग क्लस्टर हैं। विशेष रूप में कह सकता हूं कि यहाँ जो केमिकल इंजीनियर हैं और अन्य इंजीनियर हैं वो भी हमारे इंजीनियर क्लस्टर बना सकते हैं और केंद्र सरकार की इस योजना का लाभ ले सकते हैं। विशेष रूप से मैं जानता हूं कि इंजीनियर जो है वो समाज के बीच चाहे वो मैन्युफैक्चरिंग हो, चाहे अन्य कोई काम हो, उसे हमारे इंजीनियर ही करते हैं। एक संस्करण मुझे याद आता है कि एक बार एक इंजीनियर ट्रेन में सफर कर रहे थे। वो सीधे साधे व्यक्ति थे। उसी ट्रेन में बैठे हुए कुछ बच्चे उनसे उद्दंडता भी कर रहे थे, लेकिन अपनी वो लगन में मस्त बैठे हुए थे। कभी खड़े हो जाते थे, कभी बैठ जाते थे। कुछ समय आगे बढ़ने के बाद जो ट्रेन से वो सफर कर रहे थे, उसी डिब्बे में खड़े होकर उन्होंने चैन को खींच दिया। जैसी चैन पुलिंग की, वो बच्चे उनसे उल्टा सीधा कहने लगे, हमारा टीसी भी वहां आ गया, गार्ड भी आ गया। उस कंपार्टमेंट के सारे लोग इकट्ठे हो गए। कहने लगे, आपने चैन खींच दी, मुझे जल्दी जाना था। उस व्यक्ति ने मुस्कुराते हुए कहा, मैंने चैन इसलिए खींच दी कि जिस गाड़ी से हम लोग सफर कर रहे हैं, वो गाड़ी आगे जाके रेल की पटरी टूटी हुई है, और ये रेल की पटरी टूटी हुई है जिसकी वजह से एक्सीडेंट हो जाता, इसलिए मैंने चेन पुलिंग कर दी। गार्ड ने बड़े अचंभे से देखा, उसमें बैठे हुए सभी लोगों ने देखा और कहा, ये कैसे हो सकता है भाई? आप ट्रेन में सफर कर रहे हो और आपने चैन खींच दी और कह रहे आगे पटरी टूटी हुई है, एक्सीडेंट हो जाता। उस व्यक्ति ने कहा कि ना हो तो आगे चल के देख लिए, ज्यादा से ज्यादा 100 मीटर दूर पर पटरी टूटी हुई होगी। उस कंपार्टमेंट से उतर कर लोग, गार्ड और वो बच्चे सब उतर कर आगे गए। 100 मीटर उन्होंने पास में जाके देखा तो वाकई में पटरी टूटी हुई थी। वो लौटकर बच्चे और सभी लोग कहने लगे, आपको ये कैसे पता चल गया कि आगे पटरी टूटी हुई है? वो व्यक्ति कहने लगा कि मैंने ट्रेन की ध्वनि से, जो ट्रेन चल रही थी उसकी ध्वनि को सुन के मुझे आभास हो गया कि इतनी दूर जाकर पटरी टूटी हुई है, इसलिए मैंने चैन पुलिंग कर दी। तो उन बच्चों ने, उस कंपार्टमेंट में बैठे हुए सभी लोगों ने उनसे पूछा कि आप कौन हैं? तो उन्होंने मुस्कुराते हुए जवाब दिया कि मैं एक इंजीनियर हूं। मुस्कुराते हुए उन्होंने जवाब दिया कि मैं इंजीनियर हूं। अब इंजीनियर की महत्ता आप समझ सकते हैं, वो कितने योग्य, कितने सहयोगी समाज के लिए नई नई तकनीकी के माध्यम से नई नई सारी चीजों का बनाने का काम कर रहे हैं। विशेष रूप से मैं कह सकता हूं कि आज हम सब लोग यहां, जिन बच्चों ने पारितोषिक प्राप्त किया है, उन्हें मैं बधाई देता हूं। किसी लगन उसी के साथ अपने इस प्रयास में आगे सफल हों, और विशेष रूप से हमारा जो इंडियन इंस्टीट्यूट ऑफ केमिकल इंजीनियर्स जो महोत्सव है, उसे सफल बनाने में जिन लोगों ने योगदान दिया है, मैं उनको भी बहुत बहुत बधाई देता हूं। और विशेष रूप से अभी आप सब लोगों ने देखा होगा, जब लोकसभा चल रही थी और लोकसभा के समापन के 2 दिन पहले एक बिल लाया गया था, वो था जन विश्वास बिल। और जन विश्वास बिल के माध्यम से देश के यशस्वी प्रधानमंत्री जी देश की जनता की सेवा करने के लिए उन्हें कोई कष्ट ना हो, उसके लिए बिल पेश किया गया। और से बिल के पीछे ध्येय ये है कि हमारे जो छोटे से छोटे लोग हैं, जो गरीब से गरीब व्यक्ति हैं, जो पुराने जमाने का कानून है जिसका कोई उपयोग नहीं है, हर मंत्रालय में कुछ ऐसे कानून हैं जिनकी वजह से जनता को आए दिन परेशानी होती है। देश के यशस्वी प्रधानमंत्री जी ने सभी मंत्रालय को निर्देश दिए कि वो कानून की समीक्षा करें और उन कानून को जिनके द्वारा जनता को परेशानी होती है, अकारण छोटे छोटे ऐसे क्लॉज जो लगा दिए जाते हैं जिनकी वजह से बच्चों को नौकरी नहीं मिल पाती है, उन्हें समाप्त करने के लिए कार्रवाई करें। क्योंकि हम सब लोगों ने समाज के बीच देखा होगा कि गांव और देहात में जो बच्चे शिक्षा प्राप्त करते हैं और करने के बाद वहाँ की जो राजनीति होती है, उसकी वजह से या उनकी पार्टी बंदी की वजह से कुछ बच्चे पढ़ने में योग्य होते हैं, लेकिन गांव के लोग उन्हें अकारण छोटे छोटे केसों में फंसाकर उन्हें मजबूरन उसी गांव में रहने के लिए मजबूर कर देते हैं। देश के यशस्वी प्रधानमंत्री जी ने इसी के लिए ये जन विश्वास बिल लाके वो सारे जितने कानून हैं जिससे किसी किसान को कोई दिक्कत ना हो, किसी व्यापारी को दिक्कत ना हो, किसी स्टूडेंट को दिक्कत ना हो, और गरीब से गरीब जो लोग अपना धंधा करना चाह रहे हैं उन्हें भी कोई दिक्कत ना हो, उन कानून का बदलाव करें। अगर उन्हें उन कानून में सजा देने का प्रावधान है तो उन्हें शिथिल करें और जेल भेजने की जगह उनसे थोड़ा बहुत दंड लेने के बाद उन्हें ऐसे कानून से रियायत देने का काम करें। ये जन विश्वास जो बिल है उसके माध्यम से देश के यशस्वी प्रधानमंत्री जी देश की जनता को और यहाँ के हर वर्ग को वो सारी चीजें देना चाहते हैं जिन्हें आज आवश्यकता है। विशेष रूप से मैं कह सकता हूं कि आज अभी हम लोगों ने बच्चों को पारितोषिक दिए हैं। यहाँ इस व्यवस्था में लगे हमारे कुछ प्रोफेसर हैं, उन्होंने भी अच्छी व्यवस्था की थी, उन्हें भी वो पारितोषिक दिए गए हैं। विशेष रूप से मैं एक अच्छे से कार्यक्रम के लिए मुझे यहाँ बुलाने के लिए मैं इस कमेटी को बहुत बहुत धन्यवाद देता हूँ और अपनी ओर से आप सभी का हार्दिक अभिनंदन स्वागत करता हुआ अपनी बात समाप्त करता हूँ। जय हिंद, जय भारत, वंदे मातरम।
Thank you so much, sir. Now, I would like to request Shri Vishwanath Chattopadhyay, sir, to please honor our chief guest, Shri Bhanu Pratap Singh Verma ji, with a bouquet and an uttariya. Thank you, sir. I request Professor R.K. Trivedi, sir, to please honor our guest of honor, Shri Rajkumar Lohia, sir, with a bouquet, an uttariya and a memento. I would now like to request Dr. S.V.A.R. Shastri, sir, to please present a vote of thanks.
Pleasant good evening to all the participants. Honorable Central Minister of State for MSME, Shri Bhanu Pratap Singh ji, Shri Rajkumar Lohia ji, Chairman and Managing Director of Lohia Group of Industries, Honorable Vice Chancellor HPTU, Professor Samsher sir, President of ISHC, Shri D.M. Butala ji, Secretary Dr. Avijit Ghosh ji, Chairman NOC Shri Chattopadhyay ji, and Chairman LOC Professor Trivedi ji, the dignitaries of the dais and dear participants. It's once again a great privilege and honor for me to propose a vote of thanks in the 75th Platinum Jubilee celebrations of the Indian Institute of Chemical Engineers, Chemical Engineering Congress, Chemcon 2022. It's being organized at HPTU Kanpur in association with IIT Kanpur, CSGM University Kanpur, AITH Kanpur, AKTU Lucknow, and RGIPT Amethi under the banner of Indian Institute of Chemical Engineers, Kanpur Regional Center. After many decades, Chemcon has again been organized at Kanpur, the industrial state of Uttar Pradesh, in the industrial city of Uttar Pradesh, sorry. A 75th year celebration is always special, and what makes this occasion more special is that it shares a journey with the independence of the country. The 75th year celebration of ISHE at Chemcon 2022 comes at an opportune time to remind us of the significant contribution towards nation building that the institute partook over the years when our country is celebrating Azadi Ka Amrit Mahotsav with the aspirational vision of a self-reliant India. I take this opportunity to wholeheartedly thank our chief guest, Shri Bhanu Pratap Singh ji, Honorable Central Minister for MSME, for taking out precious time from his busy schedule and gracing the validity function of Chemcon 2022. I also express my gratitude to the guest of honor, Shri Rajkumar Lohia ji, Chairman and Managing Director of Lohia Group, for gracing this occasion and inspiring the august gathering by his presence. I express my deepest gratitude to Professor Samsher sir, Honorable Vice Chancellor of HPTU Kanpur, for extending full support for organizing this conference. He has always encouraged us to engage in developmental activities, and this event is one such step in this direction. I also express my gratitude to the President of ISHE, Shri D.M. Butala, Chairman NOC, Shri Chattopadhyay, and Chairman LOC, Professor Trivedi, and Secretary ISHE, Dr. Avijit Ghosh, for guiding us to successfully conduct this conference. On behalf of the organizing committee, my sincere thanks to all the sponsors for their benevolent support, without which we would not have been able to conduct this event in this effective manner. I also thank American Institute of Chemical Engineers for participating in this conference as a co-sponsor for the first time in the history. I also thank the CDS, Chemcon distinguished speakers and Chemcon invited speakers who have accepted our invitation to deliver guest lectures. They have come across from the world, across whole over the world, from US, Canada, Japan and UK. I thank the distinguished speakers also for conducting joint symposiums, 3 of them, Indo-Canada, Indo-US and Indo-Japan in the last 3 days. I am grateful to all the participants who showed overwhelming response and have come from all the corners of the country and the world to actively participate in these events. I also thank our media partners, 3 of them, Indian Chemical News, Chemical Sourcing Guide and the Mazda Pharma Guide, and the publication partners, Indian Journal of Chemical Society and Nova Publishers USA. I thank the organizing committee members for their hard work and initiative in creating this wonderful platform and bringing together the eminent researchers and scientists from across the globe. I wish and hope that the participants have taken keen interest and also will get back to the respective host institutions with enhanced knowledge. Last but not the least, I express my gratitude to all my HPTU colleagues and the entire team of volunteers who have put enormous efforts in meticulously planning and organizing this event. I thank them wholeheartedly. Thank you once again for cooperation and enthusiastic participation. At the end, I wish to ask forgiveness for all the discrepancies in the organization of this conference. So to err is human, to forgive is divine. I once again request you to kindly forgive us for any discrepancies from our side. So from my side and from the behalf of organizing committee, I once again wish Happy New Year 2023. Thank you once again for giving this opportunity. Jai Hind, Jai Bharat.
On this note, let's conclude a remarkable, memorable and knowledgeable valedictory session. Thank you very much. Now, I would like to request all of you to please stand up for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Okay,